Hello, everyone. Good morning and welcome to the Science Pavilion. Today, the theme is sand and dust storms. The first session will be hosted by and organized by the Sand and Dust Storm Regional Center in Saudi Arabia. I'm going to also ask Dr. Jud'an to come and introduce the session. Dr. Jud'an is the chairman of the GCC node and the executive director of the Sand and Dust Storm Regional Center in Saudi. Thank you.
Thank you very much. Good morning, everyone, and welcome to the session. Today, because theme of today is the land day, so we had to link sand and dust storm to the land. Our theme is sand and dust storm challenges and opportunities. And it is a full day. I think you will finish at 5:30, but you have very good speakers that will make the time run so fast. So I welcome you all, and please allow me to call Dr. Sarah Bassart to say her word.
Thank you, Juman, for the nice introduction. Welcome, everyone. Many familiar faces today in the session. I'm not really sure what I have to say, but I want to welcome all of you to Saudi Arabia, to the COP16. I'm pretty sure that you will overview all the most important scientific achievements connected with sand and dust storms during the session of today. And maybe we can start, right? Yeah, sorry, because I have the agenda not printed. It is in my mobile, but I will say that the first speaker of the session...
You call the moderator?
The moderator, it's me.
You?
No, Takashi-san, you are the moderator of this session. Then I want to introduce Dr. Takashi-san. He is senior scientist in the Japanese Meteorological Agency. He's an excellent climatological modeler, expert in dust, feedbacks, and climate. And it is my pleasure to pass the floor to you for the chair of the session.
Yes, thank you very much.
And this is the first speaker, which is Andrea.
Yes, okay. Good morning, and ladies and gentlemen. And my name is Takashi Maki from Meteorological Research Institute, Japan. And now I am chair of SDS-WAS, Asian Node Regional Steering Group. And then thank you very much for coordinating this very important event, Land Day. And I'm happy to hear, and this is my second visit to this Saudi Arabia, Riyadh. My first visit is the March 1st conference of International Sand and Dust Storm Conference. And thank you again. And today, this first session, we have 7 presentations by experts from sand and dust storm area. And first presenter is Andrea. Okay, please. She is the chair of SDS-WAS, Pan American Node from Barbados. And also she is a very, very famous researcher, and please show your presentation.
Okay, thank you. Good morning, colleagues. It is a pleasure to be here, and I do thank the organizers for inviting us to speak on various topics. And I am going to be dealing with the health impacts of dust storms in the Caribbean. Yeah. Okay, well, we get started. I won't tell any jokes, but I just wanted to say that I am a meteorologist at the Caribbean Institute for Meteorology and Hydrology. I'm also a senior lecturer in meteorology at the University of the West Indies Cave Hill campus. And as was mentioned, I'm the chair of the Pan American Regional Steering Group of the Sand and Dust Storm Warning Advisory and Assessment System. And basically, I'm going to focus on the Caribbean. a little bit about the Americas. But some of what you see will also be familiar in terms of
Front, back.
which one?
Front and back.
Oh, thank you for advancing. Thank you. Right. Okay. Go ahead. Oh, okay, thanks. Yes, thank you. Nothing. Oh. Oh, I don't see it here. That's why. I don't see it here. That's why. Okay, thanks. Yeah, I'll go ahead and start. Not a problem. Okay. Sorry about the technical glitches. So like I said, I'm going to talk about the health impacts of Sahara dust in the Caribbean. So basically, the history of dust monitoring starts in the Caribbean. In Barbados, on the eastern side of the island at Ragged Point, the University of Miami has an atmospheric chemistry station. And this was established in the mid-1960s. So this is the longest running global dust observations we have in the world. And why focus on Sahara dust? So as I mentioned, I'm going to talk about the health impacts. So basically, studies have shown that we have significant amounts of dust traveling across the northern tropical Atlantic to the Caribbean and the Americas. Now, what has happened in terms of the research? They have shown that concentrations of in the Caribbean, in terms of these Saharan dust intrusions, actually exceed the US EPA and the World Health Organization standards in terms of PM 2.5 and PM 10 for what is good air quality. And this, of course, has serious implications for human health. So we have here a diagram, a chart from Professor Joseph Prospero, who established the Ragged Point Station that has been measuring dust for over 50 years now. And in 2003, 2004, he actually did some monitoring on Barbados, and he was actually measuring the dust mass in terms of the amounts of PM 2.5 and PM 10. And what he found was that half of the dust mass was about half of it was PM 2.5, and the majority is PM 10 and under. And so we know that when we have these Saharan dust intrusions, we expect these air quality guidelines to exceed the PM 2.5 and PM 10 guidelines in terms of the World Health Organization standards for good air quality. So basically, these Saharan dust intrusions actually cause degraded air quality over this region. So there have been a number of studies looking at various health impacts of African dust, Saharan dust. So we have the African dust and air quality in the Caribbean, various studies that we have, and I'll talk about a few of those. So we found that in Guadeloupe, for example, there was a study done by Amadeo where they saw that the air pollution and respiratory health among elementary school children was degraded. The mean PM10 levels in over 70% of the schools in Guadeloupe exceeded the WHO air quality guidelines. And they found that these compromised air quality levels actually coincided with Saharan dust events. So those Saharan dust events were strongly suspected to be the cause of the degraded air quality. And this, of course, affected the respiratory health of the children. We also have other studies that show that humidity that interacts with the dust has been shown to produce particulate matter in some islands, Barbados, Grenada, Trinidad, and so on. And some of these studies found that there were increased visits to the emergency department because asthma was worsened as a result of this degraded air quality due to Saharan dust. And there are studies that, along with Prospero's that I mentioned, there are studies that agree or come to agreement that a lot of these particle sizes are in that PM 2.5, PM 10 range. That range of particles that are easily inhaled into the respiratory tract and cause problems for those who have respiratory illnesses. So some of us, or many of us who are familiar with sun and dust storms, would know about the famous June 2020 Godzilla event. It was called Godzilla because of the size and the intensity of that event, as it covered a lot of the Caribbean and the Americas, the Greater Caribbean Basin and parts of the Americas. And during this Godzilla event, we see that this is a station in Tobago, Signal Hill. The particulate matter concentration, this was during June 2020. You see that big peak there? That is PM10 in orange. The PM10 was measured at over 300 micrograms per meter cube. And this was around June 22nd, June 23rd, where the most intense portion of that Godzilla event was crossing over the eastern and southeastern Caribbean. We know that at that time, some of the regulations have changed, but the air quality guidelines roughly for PM10 would have been about 50 micrograms per meter cube, if I remember correctly, 24-hour average for the WHO. You see that is over 300 micrograms per meter cube. And other stations in the Caribbean would have been getting similar measurements, over 200, over 100 micrograms per meter cube in terms of PM10. So we know that event seriously compromised the air quality over the Caribbean region. So there are other studies in terms of air quality. We see Lewis identified positive associations between increases in outdoor particulate matter exposure and also the outpatient asthma-related visits in Puerto Rico. We also have another study from Guadeloupe. The French Caribbean has done quite a bit in terms of studies of particulate matter concentrations in Saharan dust and its impact on human health. And we see that Vail showed an association between the mean PM10 concentration and the proportion of intense dust events and linking that to preterm births in Guadeloupe. And then there was a follow-up to that study that also found a relationship between increased PM10 and low birth weight. And then, of course, there are other studies. Water quality. Some of us may not hear about that in terms of the health impacts of Saharan dust. But if we look at our region, there are other regions as well where they do rainwater harvesting, where water is actually stored in containers that may not be properly sealed, that may be exposed. So you would have a case where you have exposed drinking water supply that is going to be vulnerable to contaminants that come in the dust. So there are studies that look at that, Middleton and Kang in 2017. We also have communities that lack potable water. This has to be delivered. And we have to make sure that when this delivery is done and when the water is hauled in storage containers, that it's not exposed to the contaminants that would be in the dust as well. So things like pollutants, heavy metals, soil-borne microbes as well. We have to be very careful about that. And also another problem we might have, untreated rainwater is also higher at risk for contamination from the atmospheric dust deposition you would have once this rainwater is exposed and untreated as well. And basically, to sum it up, Peters, in a study in the Caribbean Grenadines, basically said few households exercise good rainwater harvesting practices. And this increases the risk of contamination in the storage tanks. Okay, so we also have other studies looking at bacteria that's carried in terms of the Saharan dust transport. And there's been bacteria that has been identified with possible pathogens present in the aerosol dust that's coming across in the Dakar region. There were specific studies that looked at that. They isolated a certain number or several bacteria, and they realized the majority had potential to cause respiratory illnesses or to exacerbate any respiratory illnesses. And the patients who were immunocompromised, so those are the ones that already are dispositioned for these respiratory illnesses, would actually be more at risk. And they found that this bacteria was identical to several that were found in other studies as well. So we talked about health. I put safety in here because safety also affects health. Because if you're traveling and you have low visibility, you can get injured. Something can happen. So I put safety in here as well. And I want to talk about African dust and safety briefly. There's more that I can say about it, but we don't have time. But basically, when we had this intense dust storm, the Godzilla event, we actually had very low visibility over the much of the Caribbean basin. And if you look on the left-hand side, you would see that the chart shows the visibility from the Antigua and Barbuda Met Service, along with data from the Barbados Meteorological Services. And basically you're going to see a dip in the chart in terms of the visibility around the 21st, 22nd, 23rd of June. That's when the most intense plume would have been over the Eastern Caribbean, where Antigua and Barbados are located. And what would happen is that normally you would have 20 to 25 to 30 kilometers visibility. The visibility dropped to 5 kilometers during that intense dust event, and even lower in some places. So straight off, we see the issue we would have. Fishermen actually complained that the low visibility affected their marine operations. So if you look on the right-hand side, you probably can't see anything out to sea. I actually took that picture on the 22nd or 23rd, I think. If you look out to sea, you can't see anything. But if you were to look at my slides more carefully, there is a cruise ship out there, a large cruise ship, but you can't see it very well from where you are. The visibility was that bad. And that cruise ship was not that far out because it had just left the Barbados port, the Bridgetown port, to head out to sea. And you could barely see it. And that's probably only a few kilometers out to sea because it had just left port. Normally you would see it clearly because they're huge. You can't see it there. That's how bad the visibility was. So imagine the smaller boats, fishermen that don't have navigation systems and so on, they would be in lots of trouble. So I just wanted to point out a paper that is very important in terms of our region. Daniel has led the authoring team on that paper, and that was published in 2023. And it summarized basically the health and safety effects of airborne dust across the Pan-American region. And this paper was published in Reviews of Geophysics, and it was entitled The Health and Safety Effects of Airborne Soil Dust in the Americas and Beyond. So some of what I've talked about would be summarized in here, along with other impacts in other parts of the Americas as well. So a very important paper for our region in terms of the review and summary of these health and safety impacts. So I advise you to take a read if you haven't already. So there are a number of regional and international initiatives that benefit our region, the Caribbean and the Americas as a whole. So we have the Caribbean Aerosol Health Network. We actually had this group that started as a result of looking at the health impacts of particulate matter, but we concentrated mostly on Saharan dust, on African dust, because a lot of us in that group were actually looking at dust in terms of, as opposed to other aerosols. We also have the Dust Alliance of North America, and this is a partnership of scientists and practitioners who have the purpose to accelerate the transition of dust-related research into service, and it focuses on North America. So there are a number of us who are in this alliance as well. And of course, many of you will hear about the WMO SDS WAS initiative that we are the steering committee that are here in Riyadh for our Global Steering Committee meeting, our annual meeting. And you're going to hear more about that as the day goes on because a lot of us are very involved in this initiative. So in terms of air quality forecasting, at the CIMH where I work, we actually provide dust and air quality forecasts for the Caribbean using the WRF Chem, Weather Research and Forecasting with Chemistry. We put out 7-day forecasts twice daily, surface dust concentration, PM 2.5, PM 10, aerosol optical depth, and also surface ozone concentration. So what you're seeing on the slides, or you're seeing here on the monitor, are actually animations of the forecast, some of the forecasts that we've done. On the left-hand side is the surface dust concentration. On the right-hand side is the surface PM 2.5 concentration. So of course, in terms of our region, in terms of especially the Eastern Caribbean, you're going to see peaks in our PM 2.5 as a result of Saharan dust intrusions. And the model is a useful tool for predicting these. And it has shown to have some skill in terms of the 5 to 7 day prediction of these Saharan dust intrusions. So what we've done, because we have the model tools, we've put out Saharan dust advisories for the Caribbean community health sector. Barbados and other territories are part of what is called CARICOM, the Caribbean community, and we actually send these advisories to the Caribbean Public Health Agency and the Pan-American Health Organization for them to distribute to their networks. So our air quality team, we actually put this together along with the conditions, the satellite imagery, the model predictions, and some advice. And the health practitioners, they actually add their own advice to distribute to the public health networks. And we try to get the information out there as best as possible. So I would like to thank you for listening, and it has been a pleasure to share a little bit about you, with you about what we're doing in terms of the Caribbean, and a little bit about the Americas, looking at the health impacts of dust storms. Thank you very much, and I look forward to any questions and discussion.
Thank you very much, Andrea. Very fine presentation about the health impact of Saharan dust. And do you have any questions or comments from the audience? Please.
Thank you. Thank you, Andrea, once again. Very nice presentation. Just a general question. Out of these dust, what do you think, how much of these dust come from the natural sources, and how much from anthropogenic activities like road traffic and industry and other different sources, please?
That is an excellent question. What we've actually done, and we're working on that now, we have procured, for Barbados at least, we've procured 2 TOMs. TOMs are reference method research grade samplers. And what we're aiming to do within the next number of months or year, we've placed 1 TOM on the east side of the island at the Ragged Point site. That would measure the background in terms of the Saharan dust. And we have another TOM on the west side of the island. So what we're going to do in terms of that and other samplers we have on the island, we want to look at the ratio of what we get for PM 2.5 and PM 10 on the west side of the island as compared to the east side. And that is going to give us an idea, roughly, after we do more analysis, it would be more accurate, of what are the local sources versus just the Saharan dust. So I hope that answers your question. So we hope to do that soon. We weren't able to do it before because we didn't have the sensor capability, the samplers on site.
Okay. And do you have any other questions or comments?
Hello. Voila. Ici.
Please.
Hi. Hello, bonjour. Takashi-san, arigato gozaimasu.
Thank you very much.
Dr. Seeley, thank you for your comments this morning. My name is Aziza. I'm from UNDP. So in recent years, we've seen an acceleration when it comes to desertification. Certainly a worldwide problem. Even in Canada, we have this issue in the prairies. When it comes to sand and dust storms, in recent days, has there been an acceleration in this problem? And I was wondering what might some of the aggravating factors and variables be, and what can we do as an international community to address this? Do you have, some recommendations?
Okay, I'm going to keep it very brief because there's a lot I can say about this. But what we would have found in terms of the acceleration of, let's say, Saharan dust, because that's what affects the Caribbean more so. At the source region, the land use, the desertification, etc., would affect it. But then also their atmospheric, and this is the meteorologist talking now, there are going to be atmospheric circulation anomalies in terms of what affects the transport of dust coming across. And we found that there have been some anomalies, especially with the Godzilla event, that affected the transport across to the Caribbean. So you have the source in terms of more dust that is available, and then of course the actual transport mechanism coming across. If you have an anomaly in that, then you would actually have more dust being pushed across. Now, there isn't much you can do in terms of the forces of nature, but in terms of having the tools that we need, such as the modeling, the modeling and the monitoring, you can actually have mitigation. So where we have to concentrate, at least for us, will be the mitigation, or on my side of the world, will be the mitigation and adaptation to this phenomena. So that's why we said we want to concentrate on making sure we have good predictions, we're getting the information out there to the stakeholders, because in this case, we just can really mitigate and adapt better. So that's my short answer to that question. Hope that helps.
thank you very much for the fine presentation. And now let's move on to the next presentation. The next presenter is the Professor Jordi Stenchkov, and the title is Dust Effect on Climate and Solar Devices over the Middle East. Please.
Okay. Thanks very much for organizing this nice session. So I'm Georgi Stenchikov. I'm representing King Abdullah University of Science and Technology. I was founding professor at KAUST for 15 years. And my group worked with regional impact of dust on climate, air quality, and solar devices. I mostly will focus on this regional effect in my talk. So I include both physical effect on climate and physical effects on solar devices. Please, next slide. I can do it myself, right? Just this.
Green one.
This one, okay. Okay, very good. So aerosols play a very important role in climate system. So there are multiple types of aerosols. And dust is the most abundant aerosols on the world. And I'm talking about Middle East and North Africa, the region what is called source region for dust. Dust is originated here and transported to the entire world. So the constitution and size distribution of dust and size in source regions is different than other places, and concentration is higher than in the region where dust just transported. Dust interacts with solar radiation, with thermal radiation, and it affects clouds. And if you look at the global effect of dust on the left-hand side, you see radiative forcing of dust. It could cool the system and it could warm the system. It depends on surface albedo. For example, it warms the system, climate system over deserts because they have very high albedo, but cools oceans. But dust also produces some positive effect. We found that dust layer in Sahara actually shifts rain belt to the north in summer, increasing precipitation in Sahel, and without dust, it will be even worse in this semi-desert region. If we talk about regional effect of dust, it is multiple. The first of all, it is of course effect on human activity and human health, but also dust is deposited to the seas and provides nutrients to microorganisms. It affects visibility, and on the left top, you see absorbed optical depth of dust, and you see a huge blob over Red Sea. It is interesting, dust is not generated over sea, it's generated over land, but the highest concentration of dust in summer is in the southern Red Sea. This is because of a specific geography of this place. Red Sea is narrow sea with range of mountains on the border of the sea, and the height of mountains increases when you go to south. In summer, the winds are mostly from north, and they put all the dust that is come over Red Sea to south, and it is stopped by these high mountains, and we have the layer of 2-3 kilometers of dust that have optical depths of almost 1. It is the highest optical depth in this region, and the highest radiative forcing of dust that reaches about 60 watt per meter squared. So another effect of dust that I want to show here is horizontal transport of dust. So it is wind drifting of dust. It produces sand dunes, and it affects all sorts of activities, and we begin to look at this relatively complex process. And of course, dust affects solar radiation and affects solar devices. Desert regions are very rich for solar energy, but dust could hamper this harvesting of solar energy in two ways. It attenuates incoming solar radiation, as shown here, and it deposits on the surfaces of solar panels and decrease their efficiency. So in this, I just show one of our study when we looked at the effect of dust over Red Sea. We did the first coupled regional modeling system that includes atmosphere and ocean. Ocean was calculated with 2-kilometer resolution, and atmosphere with 10-kilometer resolution. And we calculated how much dust in southern Red Sea affects its temperature and circulation. Here you see that radiative forcing blue curve reaches 60 watt per meter squared per day. We also looked at mineralogical composition of dust and how it affects delivery of nutrients into the Red Sea. For example, in this slide, 0.7% is hematite. And hematite is mineral that has iron that is important for functioning of marine microorganisms. And Red Sea, I don't stop on this, affects also circulation in the Red Sea, delaying intensifying the overturning circulation in the Red Sea. Not all of these processes can be studied theoretically. We need serious measurements that will improve our models and give us important characteristics that we can use in modeling and test our models. At KAUST, we developed versatile monitoring program. On the left top, you see IRONET system. It is one of the most important aerosol network in the world. It belongs to NASA, and we did it in cooperation with NASA. NASA, Goddard Space Flight Center calibrated our instruments and processed the data, and we have data more than 12 years. On the right-hand side, handheld sun photometer that we use on the ship, and this were the first systematic measurements of optical depths over Red Sea that last for 13 years. On the right down, you see micropulse LiDAR. It is also in cooperation with NASA Goddard Space Flight Center. We can produce vertical profiles of dust over coastal region, where the KAUST is located. And down left, you see a simple instrument that we use to measure deposition of dust. This is very important measurements. We do it for 7 years, and despite the instrument looks very simple, it requires very sophisticated processing of the data to get reasonable results. During this work, we looked at different aspects of dust. We started from soil samples, and we used electron microscope to see the dust particles, and we did X-ray diffractometry to uncover the mineralogical composition of dust particles. On the left, you see the results from LiDAR measurements. They show vertical distribution of dust loaded in the atmosphere. This yellow is coarse dust particles, and black is fine dust particles. Vertical axis is altitude, and you see the all dust is in low 6 kilometers, and this is the height of the boundary layer of a desert. Very, very intensive, very so important part of the atmospheric motion. On the right is observations of the Ironet station. It shows optical depths of aerosol, and specifically it shows the dust storm in 2012. In March of 2012, this maxima, this was the first dust storm what we detected, was very, very intensive event, and we studied it in so experimentally and theoretically. So this is observations how we process the data from dust deposition. Each sample was weighted and tested, and after then we measured size distribution of samples and did mineralogical analysis of these samples. And you see the dust deposition has a clear seasonal cycle, and on average it is about 10-15 gram per meter squared per month. So this is my group member who is working on analysis of the samples, and on the top you see mineralogical composition of average mineralogical composition of dust on Arabian Peninsula, and size distribution is on the right down. And I want to emphasize that size particles here you see reach the size of about 100 micron, and this is important. So this what we found in the deposition samples, and these particles are falling down on the solar panels, and as I said, so they decrease efficiency of solar panels significantly. And we looked at this process specifically. So the models generate dust on the formula what is shown here, and most of the bin models don't consider large particles. They look at the particles with the sizes less than 20 microns, and you saw that in deposition samples we have particles up to 100 microns. So what we did, we included, so we compared deposition rate, what calculate ordinary models, and the best reanalysis products, and compared with our observations. And we found that so observed values 3 times higher than models predict. And this is because models do not account for large particles. And we corrected this deficiency, and we are able to reproduce the observed deposition rates. So this is roughly, just shortly, comparison of observed and simulated. We can do it very, very accurately now. And we use this to calculate radiative effect of dust. Here you see so observed optical depths and simulated optical depths, and model could produce this pretty well statistically. And we looked at deposition of dust with different sizes and effect of dust on optical properties and radiative fluxes in the atmosphere. You see that we used it in our project for industry, for aqua power, to predict so the areas with most of dust deposition, so which is important for distribution of solar devices. On the left side down, you see the distribution of dust deposition over Arabian Peninsula. You see that eastern part is mostly affected by dust deposition. And this other slides, other panels show effect of particles of different size. And you see that small particles do not affect much deposition rate. And larger particles bring the largest impact and deposition rate. And if you look at radiative effect of dust on radiative fluxes, so you see that the largest effect have small particles on attenuation of solar light. And larger particles do not have large effect. That's why it is difficult to detect it optically, and we have to observe them in situ. So both type of aerosol, fine and coarse, are important, but in different ways. And we looked at the impact of dust on productivity of solar panels, and we looked at two effects of soiling losses, SL. It is because of dust deposition on the surfaces. These losses accumulate with time. If you don't clean, then will accumulate. And attenuation losses that because of suspended dust in the atmosphere and decrease of incoming solar radiation. The total losses are sum of attenuation and soiling losses. So we can theoretically calculate how this layer of dust on the surface of the panel could decrease the incoming radiation and calculate soiling losses. And our estimates show that so on average, soiling losses so accumulate about 4% decrease of efficiency of solar panels per week. So if you don't clean it for a month, it will be significant effect. And attenuation losses about 3.5%, a little bit smaller. So thank you. If you have more questions, please let me know.
Thank you very much. And do you have any questions, please?
Здравствуйте. Спасибо. Thank you for this presentation. So back in 2016, I was working for the IFC on a project called Scaling Solar. And what we were doing was facilitating public-private partnerships to build utility-scale solar across the developing world. I myself am from Canada. And when it comes to energy, we are heavily reliant on hydropower, which is great. It's clean, it's sustainable. But I am still interested in solar energy. You mentioned the impacts of dust on solar and the albedo effect of dust. In Canada, we don't really have dust, we have snow. So I was wondering if you thought that there was a similar impact on solar energy production from snow like dust. I don't know if you're able to answer this question, but please try.
No, there is something in common, not exactly. Dust do not melt. Of course, snow falling on the surfaces will decrease the efficiency. But so when we talk about snowfall, it is usually in winter when there is not so much solar radiation. So I don't think solar panels are very effective at this time. But of course, so the cleaning of solar panels from snow has a lot of similar effects with dust. But optical properties of snow and dust are different, and so in this sense, there are some differences. But definitely, so there are some connection.
Okay, please.
Thank you. Hey, George. I'm a research scientist from the United States. I consider myself doing lots of modeling work on dust simulations and their impact on the climate and weather. So one of the challenges of dust modeling is to quantify or verifying the deposition of dust on the surface. So you showed your, kind of instrument looks like a plate, gathering dust on the surface. I'm just wondering how costly, or is it, if it's not expensive, is it possible to, apply the same technology around the world and to help quantify, depositions, and how much maintenance it would require, for maybe university students? Can they do it, or, just to spread the technology that is really needed for modeling community to better quantify wet deposition or dry deposition?
Thanks very much. Very good question. So I would say the device itself is not expensive and easy to handle, but so it looks from outside. But when you work with this, it requires a lot of experience. So let me explain. This plate has a sponge that collects dust, and we do it on monthly basis. Collect dust for a month. This plate is connected with the pipe that goes to the bottle. If there is a rain, dust will be washed out to the bottle. And at the end, when we collect dust, we use distilled water to clean the sponge and collect everything in the bottle. So we have dust suspended in water. So you in desert, in hot climate, you have to be careful not to expose too long to warm temperature this bottle, because biological material begin to grow. So we bring this bottle to the lab. We freeze the bottle to minus 86 degrees, and after then sublimate the ice. It is the fastest way to evaporate the ice, not to heat it, but to cool it, and after then sublimate the ice. And so it takes 1 week to dry the sample. After then you have a sample that so you can measure in milligrams and have to work with this sample. So we weigh the sample. We do size distribution analysis using optical instrument for this. And we use these samples in X-ray diffractometry to measure mineralogical composition. So you also can do chemical analysis. This is the size of the processes what have to be done. Student can do this, but it has to be trained. We're happy to share our experience. The importance of measuring this deposition and analysis of deposition samples, they allow us to estimate the dust from two sizes. From the size of large particles, deposition samples allows us very well to look at larger particles. And optical depth that is sensitive to small particles gives us information about fine dust. So in this case, we can characterize the entire spectrum of dust particles that are very important for adequate modeling of dust.
Okay, thank you very much. And the time is limited, so we'd like to move on next presentation. The next presenter is Dr. Feras Sinat from FAO. The title is Agriculture and Sand and Dust Storm, Challenges and Solutions. Please. This green line.
Good morning, everyone. I thank the organizers for this opportunity to speak on the impact of sand and dust storm on the agriculture. The previous speakers talk about the health, the energy. I think the other speakers will talk about other sectors, because sand and dust storm is a trans-boundary and multi-sectoral issue. And there is a lot of impacts on the health, on the economy, on the transportation, and everything. But today I will focus on the effect of sand and dust storm in the food we eat and the water that we drink, which is maybe the most important thing we have. I would like to start with some figures that we recently came up with. First of all, we could say that 60% of the human-induced land degradation is happening on agricultural land, which means that our agri-food system is in danger. And if we don't act, we know that 95% of our food is produced from land. And land degradation is impacting the food production. And so we need to take action. Sand and dust storm is one of the most important degradation phenomena in the dry region. And that's why we need action as soon as possible. Otherwise, we will have issues with the food security in the future, with the water availability, etc. So FAO is working hard on transforming the agri-food system to achieve land degradation neutrality. And one of the important aspects here is the sand and dust storm and its impact on agriculture and food production. This one, okay, thank you. So let's start with some assessment of the direction and sources of sand and dust storm. We can see the whole world is affected by some kind of source and deposition of sand and dust storm. So we are all concerned about sand and dust storm. Now, human activities is the main reason. Land use changes, the mismanagement of land resources, given also the fact that climate change is impacting, together we have a big impact on the process of sand and dust storm. The effect of sand and dust storm is not only on food, on health, it affects about 11 out of 17 sustainable development goals are affected by sand and dust storm. We can see example of health, agriculture in both sides, the crop and livestock, the transportation, the energy. These are some examples of the impact of sand and dust storms. Now, specifically on agriculture, we can see here that out of the amount of sand and dust storm, there is only 25 is anthropogenic sources, which means that the natural sources is still there. But we have to work hard on the 25% that is coming from our activities to stop mismanaging and misusing the land resources in order to control sand and dust storms. So it's very important. The phenomena will never stop, because here we can see 70% is coming naturally, and that have sometimes a positive effect in forming fertile soil, etc. But the 25% we as a human are responsible for, and we have to work on very hard. Here we can see the impact of sand and dust storm in agriculture, on productivity, on the seed health, on the loss of plant tissues, etc., etc. There are a lot of impacts on agriculture, on the crop, on the plants, and in the livestock. In the right-hand side, we can see the sources, how agriculture is causing or enhancing, increasing sand and dust storm. So agriculture is both source and victim, which means that transforming agri-food system is very important, not only to provide food, but also to reduce land degradation, and sand and dust storm is one of them. We can see here some figures of devastating effect of sand and dust storms on the livestock, on the human health, on the constructions, and that's why mainly we can say that we need to take measures in the early warning, in the prediction, in the assessment of the sources of sand and dust storms, and putting some practices to reduce the source, and in the same time work on the impact area, the deposition areas, in order to adapt and manage the effect and the impact of sand and dust storms. Here are some idea about the management, how we can manage agriculture in order to reduce sand and dust storm. First, we reduce the soil disturbance and soil movement, especially in the dry areas, tillage operation, any agricultural practices. If we practice them in the wrong place and the wrong time, there will be a very big effect of that. We reduce the period where the area is uncovered, because that is where the activity of sand and dust storm starts. So it's not a matter of having a good land cover in the winter, as was explained before. It's not a matter of covering the soil in the winter, because the most important and significant sand and dust storm sources is happening in the dry season. And there we need to make sure that we cover the soil during those dangerous periods where we have high activity of sand and dust storm. So it's about both the cover and the timing in order to reduce the impact of sand and dust storms. Finally, we need to increase the soil resistance by aggregation, by putting some amendments, by proper tillage practices, by using residues, etc. There are a lot of practices to reduce to increase the soil resistant to wind erosion. Here also some examples of the sand and dust storm risk in agriculture, in the tillage, on the land use changes, in the poor crop management. All of these are enhancing or increasing the risk of sand and dust storms. And so we need to look at each area by area, to look at site by site and see what is the major cause of wind erosion or the disturbance of particles, and then try to find the solution for that. I will talk about some solutions in the later. But here also some assessment of the implication of sand and dust storm on agriculture, on the crop, on the soil, on the equipment. Also off-site, there is an impact because SDS, when it happened, it has an effect on the source areas, reducing soil fertility, doing a lot of damage on the soil structure, on the soil composition, and also in the impact or deposition area, there are chemical, physical, and biological impact of sand and dust storms. Here also a matrix, how do we assess the hazard? What is the probability of having sand and dust storm? We call it the hazard. And then the exposure, how the sand and dust storm will affect any area, because different areas affected differently by sand and dust storm. So we need to look at the characteristics of that area to see if sand and dust storm happened, how it's gonna affect that area. And then finally, something about the vulnerability, because that's very important. When we come to the resilience, we have to look at the causes, at the current situation of the area, the exposure, and then what are the set of solutions to reduce sand and dust storm risk, whether it is in the source area or in the impact area. Here are some of the mitigation and adaptation measures. We need to look at practices based on the process, because there is no one size fits all. There is always differences in the phenomena of sand and dust storm, the source, the intensity, etc., and the characteristics of the area that will determine the intensity and the severity of the sand and dust storm impact. So we need to look at practices. FAO worked with partners to collect more than 150 practices that are useful for different conditions. So if we have a dry area with this land cover, with this wind characteristics, we have certain practice. For other area, we have different practices. And these practices also not take into consideration only the physical condition, but also the human dimension. Because we cannot ask people to cover the land with a green vegetation if they don't have the means, if they don't have the financial resources. So we have to be mindful of the people capacity to do these practices, where, when, and how. This is some examples. This map on the left shows where are the areas around the Central and West Asia and North Africa where we can implement water harvesting to reduce the effect of sand and dust storm by vegetation, by making some structures to reduce or to increase the soil resistant to soil erosion. And these practices proved some good results. We measured the erosion that happened in those areas compared with bare areas, and there are very positive effects. In addition to this also provides sources for feed for the animal. That's why the farmer will get excited to do it. Otherwise, they will simply don't do it. But if there are other benefits, I think the people will start to adopt these techniques and put it on their farms. Finally, I would like to bring to your attention some recent publications from FAO and partners. One on the Guide for Mitigation, Adaptation, Policy and Risk Management Measures in Agriculture. This was launched in November last year in the CREC meeting of UNCCD in a preparation for COP. There is also more specialized report on the crops from Islamic Republic of Iran. And there is also a third publication from Mongolia looking at the impact of sand and dust storm on livestock and what are the measures that we can take in order to reduce the impact on livestock. I would like to finish or end this with looking at the scientific information. I thank Professor Giorgio for the very interesting results, the scientific results. We still need more, in fact, in the assessment of the process, the impact and the mitigation, and we need more on the economic and social impact. And how can we suggest to the people practices that will be affordable, that will be achievable, and we don't keep asking the people to do things that they will never do. Sometimes we think that this solution is the best, yes, but the people cannot afford it. So we need to think about the practicality, the efficiency of any practices that we are providing. And FAO is always ready to support partners and countries to find solutions for specific conditions and scaling out those practices that proved to be successful in some areas to be scaled out to other areas. I'll stop here. Thank you very much.
Thank you very much. And sorry, the time is limited, so one quick question or comment, please. Okay? Please.
Thank you very much. Yasser Kala from NCM. Thank you for your presentation. And you mentioned about the strategy of mitigations. So what do you think about the important or the most effective strategies for mitigating the impact of sandstorm on agriculture? Thank you.
Thank you. This is very simple, but very big question. Yes, we try to analyze the issue. Like, first of all, we need to understand the sources and to assess the sources. And I am glad also Professor Lahmoud with us from Kuwait. They managed to identify the source area not as a general area, but as its hotspots. We call it hotspots, where the dust is coming from. And then we try to implement practices to reduce the source, because that is, I think it should be the first step. Second step, as we said, 75% is natural. So whatever we do in order to reduce those hotspots, there will be always activities of sand and dust storm. So we need to adapt. In agriculture, as we mitigate in the source area, yes, adaptation in the deposition and the impact area. So we need both. We have the 150 plus practices. They are divided into mitigation measure and management and adaptation. And we like, in sand and dust storm, I like to say management more than adaptation, because we need also not only to adapt, we have a role in reducing. So managing the source and managing the impact, I think, is the complete set, which also entail mitigation and adaptation. Thank you.
Thank you very much. And let's move on next presentation. The next presentation is from the Dr. Anna Bikovic from WMO SDS was NAMUI node. Please start your presentation. This one, this button, this green button.
Hi everybody, I'm here as a representative of WMO. SDS was for the NAMI node, but my subject here is much wider and related to the whole world. I will talk about climate change impacts on the increasing dust storms. So I will start with a citation from the recently published article in the magazine Forbes, which actually addressed the whole world. It says, it starts with the words, if you haven't done it already, it's time to add dust storms to your long list of the worst environmental crises of the 21st century that we are not prepared for. So this means the whole world is under the risk of the increasing sand and dust storms, and they are not just the problem of arid and semi-arid regions. So what we know so far about climate change impacts, I will go through the main references which are most effective for the policymakers, and these are summaries for policymakers of the IPCC report related to climate change, how they so far see the problem of sand and dust storms. In the summary for policymakers in the IPCC special report on climate change and land, sand and dust storms are well recognized according to the knowledge by the 2019. So they recognize that there is increase under climate change in the Arabian Peninsula and broader Middle East, also in Central Asia. Nothing about other regions. Then they refer to some reference showing that dust emissions have increased significantly since the late 19th century because of the climate change. And even the 50% of this change is driven by climate change and 40% by land degradation processes. And also they say that more sand and dust storms worldwide will be caused by changes in precipitation and atmospheric circulation. So it's partially true, because not only changes in precipitation, but also severe increase in temperature, which amplifies drought all around the world. So the drought is also becoming a worldwide problem. So another significant publication in the sixth assessment report of the IPCC, Summary for Policymaker, relates sand and dust storms as climatic impact drivers under the wind hazard group. It does not recognize that sand and dust storms are actually driven by increase of temperature and increase of droughts and aridity. So it can be a problem because it causes underestimation of this problem. It's not only related to changes in wind patterns. There is a low confidence in direction of change in Africa, Asia, South America, Europe, and there is they say now there is a medium confidence in the increase in Australia and parts of North America. So some other conclusions are drawn in the 6th assessment report. Afterwards, there are numerous new publications also in this region showing the increasing dangers of sand and dust storms related to climate change, confirming also from observations that there is increase in Middle East. There is high latitude dust increased very much in significance in polar regions, which is totally unexpected and unknown under the conventions. And about 57% of dust deposition on snow and ice in polar region actually comes from local sources in polar regions. So actually it can amplify the melting in the north and south, which is very dangerous, which can change the global circulation patterns in atmosphere and in ocean. So we know that dust, natural dust, has a very significant impact on our climate system, interacting with energy cycle, dust cycle, energy cycle, water cycle, carbon cycle. But what is very specific with dust is that it originates from local conditions, but can have regional or global impacts. So if you compared it, as they compared it in IPCC report, with hail, with floods, it's very specific. It has much larger impact area than any other severe local event. So this is why our attention of science, of global science, is bring to sand and dust storms. And actually these severe local events feed the long-range transport, which has a global impact. What is important in sand and dust storm? Atmospheric circulation, wind transports dust, and sources. Sources, we say sand and dust storms, these are areas which provide the dust particles from the atmosphere to the atmosphere under the high winds. So climate change impact both. Also, atmospheric circulation intensifying severe winds, wind gusts, frequency and intensity, and impact land degradation, causing more existence of more and more sand and dust storms, sources. I will focus now to sand and dust sources. These are the impact drivers of sand and dust storms, actually the factors which cause formation of sand and dust sources. There is a human activities. Human activities cause the generation of so-called anthropogenic sand and dust sources, which are the result of direct human impacts, tillage, water scarcity, livestock breeding, mining, and so on, and indirect human impacts through climate change. So direct and indirect human impacts change the structure of the soil characteristic, reducing soil organic matter, then change land cover, and climate change impact change in soil condition, moisture, and temperature. So here are given some examples from Europe, how land degradation caused the formation of local dust sources, how, for example, Urmia Lake in Iran, water scarcity can cause spreading of dust sources and retrieval of glaciers. So it happens all around the world in different ways. Climate change, when we want to assess the impacts of climate change, usually it's not that well studied. We address to average changes in temperature, average changes in precipitation, but there is much more hidden signals of climate change which can cause increase in sand and dust storms. Meaning there is increase in heat waves, which are causing to left soil unfrozen in polar regions, and these are seasonal sand and dust sources. Then they trigger flash droughts, which also cause seasonal sand and dust sources. There is a change in average soil moisture, as you can see, in many parts of the world, which will cause increase in aridity. Even the semi-arid climate will enter Europe, for example. And we expect more local sand and dust sources. So it's a very complex interaction between climate change and sand and dust sources. Here are just given just some random examples all around the world, different parts of the world, which are connected with the same problem, sand and dust sources appearing very frequently in Iceland. Then some of them from long-range transport from the east or from the south affect also Germany. There are local sources in Poland. There is long-range transport impact in Alps. Many dust sources, dust storms in China, as we all know. Local severe events in USA. Some of them even in Brazil, which is very humid climate, in regions that actually are not common to have sand and dust sources, Iran, and so on. We have put million pictures all around the world like this. So where this comes from? This is what we saw in the previous presentation, the dust belt and the main sources in Australia and South Africa and America, and the famous dust belt, which is in Africa, actually Sahara, and Asia. So these permanent dust sources, which produce natural dust, occupied about 21.6% of total land of our Earth. High emission potential have 7.7 of permanent sources. They can produce very severe dust storms. And you can see in latitude distribution, it's clearly visible that the largest amount of dust sources is in the dust belt. And there is no permanent sources in high latitude dust. But when we include in our map all seasonal sources and sources which appear during droughts and heat waves, we have a totally different image. 42.8% of our total land area can produce blowing dust and sand and dust storm event. 13.2% of total land area of planet Earth can produce severe sand and dust storms. As you can see now in your latitude distribution of the sources, now also the sources in dust belts seasonally intensify, which is not that well known, and new zones of dust sources appear like high latitude emission zone. So totally different picture. So in this map, in blue areas are those temporary sources. So 21.2% of total land surface of planet Earth act as temporary sand and dust sources. 5.5% of them can produce severe dust storms, and they're not recognized in our policies around the world, in our plans for reducing risks, and so on. Under climate change, these temporary sources can shift to permanent sources due to climate change impacts and land degradation. And furthermore, under climate change, new temporary sources can appear. So this is why it is a global hazard. These sources are mainly from croplands and some degraded grasslands. So for example, if we take some totally unknown region in our sand and dust storms studies, which is situated in Europe, and we enlarge this region, we can see how much seasonal sources we have. This is Hungary. This is Pannonian Valley in Europe, Southeast Europe, which is much affected by droughts because of the climate change and land degradation because of the agriculture. So you can see there are many, many surfaces prone to, nobody heard of that ever, that there are problems with dust sources. This is why this is a good example. You haven't seen it in any UN map or publication which addressing this problem. So it is actually a material, sedimentary material remained from a Pannonian Sea, which dried out a long time ago. So it's a very good soil texture for producing dust storms. So what happens there? And we are not aware of that. There are starting to appear, due to increased land degradation and increasing droughts, some very severe dust storms which are reducing the safety of the people. People over there are totally unprepared. This is unexpected phenomenon. So we had, during the last years, many events in Hungary, in Serbia, in Slovakia, causing car crashes. In Hungary, there was 42 vehicles, 39 injuries. In Serbia, 14 vehicles, 10 injured. In Slovakia, I don't know the data. So this is only known to us from the news. There is no record there, nothing. So this is just one example. You have these examples all around the world, and the science, global science, is still not aware of this. So at the end, key messages from these and also previous presentation and all what we talk about so far, and we'll talk about today, is that sand and dust storms are a so complex problem, and they're actually the embodiment of land degradation, but are not well known to the policy and to the common people. It is so complex that UN coalition is formed for combating sand and dust storms with 19 UN and non-UN agencies. It is enhanced by climate change to the level of high-level risks around the world, but there is no UNFCCC is not included in our talks in combating sand and dust storms. They are not that aware of it. And also, the sand and dust storm impact 11 SDGs. So new reports, as we saw, are available from FAO, will be available from WHO. Everybody are doing their work, but there is no comprehensive approach to combat sand and dust storm and mainstream into all relevant policies of the countries in the world which are affected or will be affected. So also Lancet Countdown in 2024 adopted the sand and dust storms as a new climate indicator, which is a big thing. According to damages as losses, cost, injuries, lives taken per unit of time, if you count the costs per unit of time, sand and dust storms could be one of the most dangerous hazards in the world because they are short-lived, they'll kill in the moment, they cause so much damage in just a couple of minutes. So one of the recommendations here is that UNFCCC should be included in the activities related to sand and dust storms because other Rio conventions are and other UN agencies are. Also, it could be maybe some option to propose to IPCC, which would serve also to other conventions, to develop more hazard-oriented special reports and maybe special report on sand and dust storm. We know these reports of IPCC special reports are most effective in policy making, so this could help very much to plan proactive measures and prevent this hazard to spread and damage the whole world. Thank you.
Thank you very much. And the organizer requested me to stop this session before 11 o'clock. So I'm sorry that if you have any questions or comment, please do so at the break time. And then I'd like to move on to the next presentation. And we have from now 3 presentations, and I requested presenter to, sorry for but please shorten your presentations. And the next presenter is the Dr. Ali Al-Hamad, and the title is Sand and Dust Storm Contribution of PM 2.5 and PM 10. Sorry for the inconvenience. Please start. This green one. Please start.
Assalamu alaikum. My name is Dr. Ali Al-Hamoud from Kuwait Institute for Scientific Research. And my presentation is related to sand and dust storms contribution to PM2.5 and PM10. Yes. Okay, this is basically a project which is funded by Kuwait Arab Fund for Economic Development and also with the United Nations Habitat, UN Habitat. And it is a research from Kuwait Institute for Scientific Research. The topic is related to improved resilience to transboundary sand and dust storms. This is the title of the project. So basically, first I will talk about the sand and dust storms over the Arabian Peninsula. Then I will talk about specifically for a major sand and dust storm source, which is in South Iraq. Then I will talk briefly about the site visit, hotspot using satellites, images, and lastly, I will show a susceptibility mapping and some recommended techniques. So basically, there are 10 major, we can say, dust sources that affect the Arabian Peninsula. The first one, as you know, is the empty quarter. The second one is our study, which is in South Iraq. The third one is in Syria. The fourth one is in Jazmorian. Then the Sahel, the West Sahel of Iran. Then also Zabul Lakes, Hamun Meshkal. There is also Rajasthan, India, Pakistan. There is the one in Egypt and Sudan. Now these are the major 10 sources which affect the Arabian Peninsula. Now we are studying only one source, which is South Iraq. Basically, as you can see this, we are using remote sensing satellites using Aqua and MODIS. This is a map in June 2021. And as you can see, this is the major dust source in South Iraq. This is our study area. This is, as you can see, this is very major dust jet, which travels from the South Iraq and affects Kuwait, and travels, by the way, crosses Saudi Arabia and goes all the way to Qatar. This is the major source. And this is by also another satellite from Sentinel. This is in June 2021. This is the major dust source. Another also images, we are observing this dust source for the past 10 years. This is the major dust source. Now this is our visit. Before signing the contract with the UN Habitat, we visited the area in 2019. And as you can see, there is a sign where is this is, by the way, this is a major highway which crosses from Kuwait to Iraq, major highway. This is the, you can say, the major dust source area, and there are also hotspots within the area we will identify. As you can see, the soil is very fragile, very fragile. So when we drive on the car, or even when we walk in the area, as you can see, it becomes very fractured because it's mostly loamy sand area as well as clay area. So when there is high wind, of course, there will be fine particles which emit from this area and crosses all the way because of the northwest direction. This was only 2 months ago. We visited the area. As you can see, there is also animal grazing in the backyard. There are some sand dunes as well. As you can see, this area here, we are putting now, we call it dust traps for analysis, and we have done also a lot of analysis. Now, this images from Sentinel area, as you can see, for example, this is the highway which crosses the two countries, Kuwait and Iraq. This is also another zoom in of the dust source area, April 28, 2023. This is the major dust source area. Why I'm showing you these images? Because later on I will show you the susceptibility hotspots within the area. Because as I said previously in the presentation, there are 10 major dust sources. So when we consider Iraq's dust source, there's a big dust source. It is 1,600 square kilometer. Now, within this dust source, there are major hotspots. That's why we have to identify. Also, using Landsat, April 23, 2023. In other words, we are using different satellite processing techniques, Landsat, MODIS, Aqua, and Terra, as well as Sentinel. Now, basically, in April 2nd, 2023, this is a vegetation, normalized difference vegetation index. As you can see, there are, we can say, in the orange color, there is poor vegetation. In other words, from satellite, we can find out that there is very poor vegetation, one on the north and one in the south. But this is from satellites, NDVI. This area also, as you can see here, this is the one on the left, this is the major dust source area, and the one in the right, this is a zoom in using Landsat. And this is April 18, 2023. As you can see, there is a line in between, which is the major highway. Now, this is the dust source study area in the Tigris and Euphrates basin, ما بين النهرين. Now, this is our project. What we have done. Basically, we have used different techniques. We used to determine the dust drivers using machine learning techniques, artificial intelligence. So we have used different types of dust drivers, elevation, slope, aspect, as well as precipitation, wind speed, NDVI, land use and land cover, as well as the soil texture. So we have used 15 different variables as drivers to determine what are the major drivers which causes these sand and dust storms. And also we have done visual interpretation using MODIS, Terra and Aqua for 22 years, from 2000 to 2021. We have processed 22 years images from satellites, MODIS and Aqua. And then we have done the modeling using machine learning techniques. We have used 4 different models, LDA, LMT, XGB, gradient boosting layer, as well as the tree-based. So we have used different types of analysis, basically 2. One is remote sensing techniques based on Aqua and Terra, MODIS, and the other, we used machine learning, artificial intelligence techniques. Now, as you can see, using MODIS, Aqua, and Terra, this is the hotspot area. Now, this is our area, which we call it the dust source, al-masdar. But in the dust source, there are hotspots. And these are, and the red shows there are some hotspots. Basically, this is June 11, 2006, as well as 2011. So we are, in other words, we are using spatio-temporal time series studies. Spatio-temporal time series studies. We are observing this area since 2006 until now, so almost 20 years. We have used different types of spatial patterns, as you can see here. For example, temperature, humidity, vegetation index, water bodies, as well as the soil types, temperature. So different types of techniques we have used in terms of which of these dust drivers are most important. Precipitation, wind speed, soil texture, NDVI types, and other drivers, 15 types of drivers. Now, using the machine learning, we selected 4 study periods because our study is from 2000 until 2021, 20 سنة. So we did not take this 20 years completely. Why? Because this 20 years, there are some dry periods and there is wet periods. So there is a dry period there, then wet period, dry period, and wet period. Depends on the years. For example, 2000, 2005, 2006, 2007, 2008, 2011, and 2011 up to 2020. And this is a very important methodology because in different periods you will have different hotspots, as you can see. For example, in 2004, from 2000 to 2005, in our area, there are mostly in the northwest. In the wet period, there are less hotspots. In the dry period, again, mostly in the north. And in the wet period, it is different hotspots. So 2000, 2004, dry period, wet period, dry period, 2008, 2012, and 2013, 2021. And this is very important technique when you do research, because you want to break the periods of the dust source events, because this will affect what are the drivers of these dust sources. It depends on the periods, because there is rain period when the soil is wet, and there is dry period when there is dryness and less precipitation and high wind speed and so on. As you can see here, of course, from June and July, this is the most dust events which occur for the 20 years, as we all know, June and July, and some in April. This image shows that precipitation is important, because when there is lower precipitation, there is high dust events. But also, it is not only precipitation by itself, because when we look at this, let's say in 2000, and this year here, there are many dust sources. In 2009, many dust sources, lower precipitation. But in other years, for example, also there is many dust sources, but also precipitation is more. So we cannot only say because of the rain we get dust storm. It's not that simple. That's why we are using machine learning, artificial intelligence techniques. So we had identified what we call susceptibility maps. Susceptibility, or it means vulnerability maps. This is the major hotspot area during the different periods. Dry period, also dry period, and wet period. And the one in the middle, this is the hotspot area. As you can see, all the area is extremely high susceptibility to wind erosion and dust events. Dry period, and wet period. Now, this pie charts show that basically in red, about 14% of the area, 14% in red, and also the orange, we can say about 20% of the area is extremely high to extremely susceptible to wind erosion. 20% of the area is extremely susceptible to wind erosion. This is basically this is an important, what this shows. This shows the drivers, the importance of the drivers which emit the dust. Number one was precipitation, al-matar. Second one, NDVI. Third one, wind speed, then valley depth, and so on. So we can consider that wind speed, precipitation, as well as NDVI, these are the most three important dust drivers, which causes the higher susceptibility of the area. We published this paper just recently in this journal, if you are interested to read it. Now, this is this is our area. As you can see, this is the area and the impact area, which goes from southern Iraq to Kuwait to Saudi Arabia and further down. And these are the major hotspots. As you can see, this is the major dust source area, and these are the hotspots within dust source area. So the red dots are the most important, which we need to consider. Now, using also MODIS Aquantera, we can identify there are two hotspots within the big hotspot. One is the one which is in orange, and there is one in the south. These are the two areas. And now, basically, in conclusion, what do we recommend? This was shown by Dr. Firas. This is one important technique that they are using, for example, in Jordan. We're using Valorani tractor before the rainy season. For example, now it's a good time to do this, for example, excavation of the area before the rainy season, and they put plants. Water harvesting. And as you can see, this is in Jordan in 2017, 2018, and 2019. In only 3 years, there was vegetation. Another technique that also they have done in Uzbekistan and at the Aral Sea, they are using aircrafts for aerial seeding, and they have basically, they drop some native vegetation plants, and then based, of course, on the soil type. And this was also very successful using airplanes, and this was done successfully in Uzbekistan, which I visited last year. Another technique basically is they are using solar panels. And this has been done in China, and you can see, for example, between the solar panels, there will be some vegetated types. And this can be also recommended for the South Iraq. Now, this is my last slide. My last slide, basically, the recommended technique which has been considered for implementation now in Iraq. Basically, they will dig some channels, water channels, يحفرون قنوات مياه من النهر from the river. There is one from مبزل الفرات الشرقي, and then they make channels to the area. And there is also another channel they will make from النهر الثالث, they call it, which is salty water, down, and also from another channel, a third channel. This is a good recommendation, but it's very costly and also very time consuming. This is my last slide. And basically, in conclusion, this research has been done in Kuwait for the past 6 years, and we have used different techniques. We have published a lot of papers on this area. We visited the area. We have done chemical analysis, physical analysis, even radiological analysis, and we have given a lot of recommendations. And now the project has passed 2 years. There is 2 more years remaining for the project, and the remaining 2 years will be considering also taking more remote sensing data and making more rehabilitation and vegetation of the area. Thank you for listening.
Thank you very much. And the organizer mentioned me that the break time is fixed from 11 to 11:15. So we'd like to move on the break time. And let's come back 11:15 and see you again. And thank you very much for all the presenters today. Thank you very much.
floor. Ladies and gentlemen, the next session will start in a few minutes. Please take your seats. Ladies and gentlemen, the next session will start in a few minutes, where we will be announcing the international partnership to enhance early warning system for sand and dust storms. Ladies and gentlemen, please take your seats. We will be announcing the international partnership to enhance early warning system for sand and dust storms. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the inauguration of Saudi Arabia Inactive International Partnership to enhance early warning system for sand and dust storms. Ladies and gentlemen, it is my great honor to introduce you to the distinguished speaker who will be inaugurating this important initiatives. Please join me in welcoming Dr. Ayman Ghulam, the CEO of the National Center for Meteorology, to the stage to officially launch the global partnership to enhance early warning system for sand and dust storms. Dr. Ayman.
Excellencies and distinguished guests, it is both a privilege and an honor to stand before you today to launch a vital global initiative aimed at combating one of the most pressing environmental challenges of our time, sand and dust storm, SDS. Across the globe, millions of people are affected by these recurring and destructive phenomena. Every year, an estimated 2 billion tons of dust are emitted into the atmosphere, disturbing lives, economies, and ecosystems. More than 330 million of people are impacted, and nearly 14% of the world's children are exposed to the harmful effects of SDS, which include respiratory diseases, heart disorders, and adverse impacts on agriculture, infrastructure, and the environment. This is where today's initiative becomes not just relevant, but essential. Today, I'm proud to announce the launch of the Global Partnership to Enhance Early Warning Systems for Sand and Dust Storms, an ambitious and transformative initiative aimed at improving forecasting, mitigation, and response capabilities worldwide. This partnership will bring together the World Meteorological Organization, WMO, for regional sand and dust storm centers under the auspices of the WMO. The Sand and Dust Storm Regional Center in Jeddah, the Barcelona Dust Center, the Beijing Dust Center, and the Pan American Center in Barbados, with the shared global of enhancing early warning systems, critical research, and providing much needed support to vulnerable countries. The core objective of this initiative is simple yet profound: to save lives, protect livelihoods, and strengthen resilience against sand and dust storms. By fostering international cooperation, leveraging scientific research, and improving data sharing, we can build a stronger system that predict and mitigate the impacts of these storms. This global partnership is more than a collaboration of regional centers. It is a commitment to enhance cooperation between governments, UN organizations, research institutions, and the private sector. Together, we will address the root causes of sand and dust storms, issues such as land degradation, poor land management, and the climate change, while improving our ability to forecast and respond to these phenomena in real time. As the Kingdom of Saudi Arabia, we are deeply committed to this cause and are proud to support this initiative. We are investing 10 million over the next 5 years to ensure the successful launch and implementation of this global partnership. This investment reflects Saudi Arabia's unwavering commitment to combating environmental threats and advancing sustainable development, particularly in the region where the impacts of SDS are most severe. Our commitment to environmental stewardship extends beyond these initiatives. In 2021, His Royal Highness Prince Mohammed bin Salman bin Abdul Aziz, Crown Prince and Prime Minister of Saudi Arabia, launched the Saudi Green Initiative, SGI, and the Middle East Green Initiative, MGI. These landmark initiatives aim to scale up climate action, reduce carbon emissions, and combat land degradation, complementing our efforts to mitigate the impacts of SDS. By addressing environmental challenges like land degradation and climate change, Saudi Arabia is supporting the Sustainable Development Goals, SDGs, particularly Goal number 13 on climate action and Goal number 15 on life on land. This declaration reinforces the urgency of our collective efforts and calls for global cooperation to tackle this critical issue. As we embark on this critical journey, we recognize that no single country or organization can tackle this challenge alone. This partnership will be a model of international solidarity grounded in the principle of knowledge exchange, capacity building, and data-driven solutions. By working together, we will achieve more than we could ever accomplish in isolation. Distinguished delegates, we are at a pivotal moment in history. Sand and dust storms are not just a regional issue. They are a global one, with far-reaching consequences for the health, safety, and well-being of millions. But through collaboration, innovation, and dedication, we have the power to turn the tide. Additionally, we also recognize the importance of the UN's Declaration of 2025 10-20 34 decades on combating sand and dust storm, which will play a crucial role in raising global awareness and the response to SDS. As we launch this initiative today, we call upon all nations, UN organizations, and partners to join us in this collective efforts. Together, we can ensure that the world's most vulnerable commitments are better equipped to face the challenges of sand and dust storms and to safeguard our shared future. Thank you.
Thank you, Dr. Ayman. Now we present to you a short film. I would like to present the Executive Director for the Regional Center for the Sand and Dust Storm, Mr. جمعان الغامدي. القحطاني عفوا.
Thank you very much. Assalamu alaikum. It is my honor today to just highlight the initiative and how we will implement it. Next, please. Maybe I should do the next. Where is the pointer? Yes. Oh, sorry. Thank you very much. Thank you. So, as Dr. Sorry. The objective of this partnership actually is to complement what the WMO and UN organization trying to do. We realize that we have big problem with sand and dust storm. And we believe that giving early warning in a timely manner to the people and to the public and private sector will help them actually to mitigate their impacts. Not only that, but we need to expand the science and knowledge of these phenomena and develop new techniques to monitor them and to predict them, to enhance the modeling capabilities that we have now of this phenomena. You know the challenge that we have with the sand and dust storm, and I don't want to dwell on this because you are all familiar with and we listened this morning to their impact, and also the climate change prediction actually predict that it will enhance, and we will have, as Dr. Ahmed mentioned, more maybe hotspots, and what Anna mentioned today, that there are more in areas where you don't expect to have dust and sandstorm, but it start to appear. Now, what we will do, we thought of establish a partnership between the WMO Sand and Dust Storm Centers and the WMO itself, and this collaboration actually participate or develop the plan to actually expand knowledge, organize workshops, participated in conferences and seminars, and help the poor countries to have an early warning for the sand and dust storm. The organizational structure and governance, it will consist of board directors, consist of the chair of all the centers, and WMO, and the chairman of SDS WAS and GSC and WMO. And of course, we can invite other organizations either as observers or members. That will be decided by the board once we establish it. The next issue is the financial support, which is vital. If you want something to work, you have to have the support, the money. And the Kingdom of Saudi Arabia, as Dr. Ayman mentioned, are going to fund this initiative with $10 million over the next 5 years. We expect the organization, WMO, and nations to help this initiative to continue in the future. Without their financial support, the initiative will not fly in the future once we have the 5 years over. But not only that, I think 2 million is not enough every year we need more money. It's launched today, and we ask all the nodes to get support of this initiative from their members countries, especially those countries who can support, because we aim to go to the poor countries and help them to establish early warning system and to develop new technologies, either in observation or forecasting, plus, of course, organizing the knowledge sharing methods like the seminars, short courses, workshops, etc. So in conclusion, this partnership we think is vital. It's very important. So we put in action what WMO is trying to do, and I thank you very much.
Now I would like to ask Dr. Ayman Ghulam, Sarah from WMO, Daniel Tang, SDC, WAS, Anna Nemi Nodes, Andrea Ban, American Node, Takashi Asian Node. For a group photo, please.
Hello, are you ready? We'd like to restart the first session. And next presenter is Dr. Southern Nichkovich from Siberia. And the title is the Technology in Monitoring and Mitigating Dust Storm Impacts. And sorry for our time management, the time is limited. So please have your presentation about 10 minutes, okay?
Thank you, Takashi. And I will need the pointer in one moment. But anyway, before I start with the presentation, my name is Slobodan Nichkovic, coming from the Hydrometeorological Service of Serbia, where more years we are also doing the dust forecasts. That's one thing that I wanted to, okay, that's the kind of next, right?
Next is.
Yeah. At the same time, I am one of the members of the scientific committee, WMO committee, and by chance participate in development and setting up the SDS-WOS, Sand and Dust Warning and Assessment System of WMO from the early days. So I hope that there are things that could be of interest for you to hear. Before I start really with the presentation, I cannot skip but say how I'm impressed with the dedication of our host today in this meeting, National Meteorological Center of Saudi Arabia, who became in rather short time, took them shorter time than for other activity nodes of this SDS-WOS dust WMO program. So in less than, I would say, maybe year or so, they became the center for GCC countries. And not only that, but they invested a lot of effort, manpower, technical, to establish this center working. And on top of that, this really big news that Saudi Arabia invest $10 million to enhance the activities in the region. Thanks a lot to our host for all these actions. So let me then start with my presentation. I will talk about components of the technology, how we monitor the atmospheric dust process, and also I will give a number of examples where we try to help the community to reduce negative impacts of dust, but also to better understand the process and somehow to transit our scientific knowledge to some practical activities and things like that. Okay. So I will not repeat some of the things that we already heard this morning, how dust becomes so important thing. I would just listed here a few international activities. One of them is WMO SDS-WOS. I will get back to that point a bit later. In Europe, we had finished recently so-called cost in dust project where we insisted on a collaboration of different groups in Europe, but also out of it, everything related to dust issues. Then UN-SG SDS reports, annual reports where SG include prepared material every year related to dust storms. And not last, but very important, UN Coalition to Combat Sand and Dust Storms. So, following the large interest for dust in general, WMO started 2 years ago to develop a publication to summarize, in fact, activities related to SDS. And next week, we expect that during this COP, the publication related to what I'm talking about, these guidelines on sand and dust storm, mitigation will be available in printed form. Unfortunately, we expected to have it these days, but anyway, it is coming anyway. So these guidelines actually have several objectives. First, very important, is to present technologies used by WMO for dust-related monitoring, forecasting, impact assessments. And the other important goal that you can find in these guidelines is to improve user-oriented dust-addressed warning services. So, talking about SDS-WOS project, this is the longest lasting UN-based project addressed to dust. In 2003, almost 50 countries, WMO members of WMO expressed interest to participate in activities related to SDS, and the concept of the project was proposed at that time. And then, thanks to accumulated knowledge and experience in dust research and observations and operations, 2007 WMO Congress approved this SDS-WOS project. SDS-WOS goals are to better understand first the process itself, to advise on warnings. I didn't mention explicit title of the project, and this is Sand and Dust Storm Warning Advisory. WMO cannot push the countries to do the warnings, but can do advisory for warnings, and that's up to countries to implement or not. And assessment system. Assessment means to study, to analyze the process of dust on a longer term. And of course, in all these activities, this was very important for us in WMO, always to look how the research results related to dust are moved or translated to be used for different users and to perform some operations. So this was the concept from the very beginning of SDS-WOS. In first years, we had started with the two activity nodes, Asian and NAMI node. In the meantime, two more nodes has been established, Pan American, and the most recent one, as you can see here, is for GCC countries coordinated by Saudi Arabian colleagues. And definitely the interest and community is growing up over years. Some more things, more information for different dust impacts. And I will always select some particular impact and try to illustrate how what are the ways to reduce the negative impacts or to enhance better knowledge of impacted environmental issues. So these pictures I just borrow from INDUST project, where you can see visually what are different activities, human activities, economic works, and so are affected by dust. I will not go into details. I think for most of us this is obvious, and we already heard this morning what are positive, what are negative, and what communities has to do to deal with the dust process. As a starting point to understand the process, of course, we have to start with good observational networks, and here are some examples, some photometers, which are at the global level, then a global map of LiDARs. LiDARs just look what is the profile of a particular site, including dust that can be recorded as well. I would like also to mention what Anna Vukovic, and she was talking a bit about sources. And I have to say that in 2023, UNCCD WMO published SDS Global Source-Based Map. This is in digital form, 1 by 1 kilometer, in principle available to users. I mean, data are numerical, and I'm quite sure that it will be turning point for many new studies based on that. And finally, not finally, but one of the important source of information come from satellites. Dust modeling. Dust models can be used in two ways: to make short range or medium range forecast of dust, and the other one is, to be used for climate, for example, assessments. And what are basically our dust models? This is our typically numerical weather prediction system, predicting wind, moisture, temperature, and so on. And then we add as an additional equation or additional parameter dust concentration. To do this, of course, you have to cover on the left down all the processes which are related to dust atmospheric process, from emission, turbulent diffusion in the vertical, long-range horizontal transport, and finally deposition. All these components has to be included in particular dust model. So here is just one daily forecast example, but also out of this data that are produced at many places now, I would say probably several tens of dust models exist today. You can extract additional information and try to show in semaphore-like examples what was done for Mauritania, a kind of warning for the people where to expect more or less dust on a daily basis. So this is the cycle that has to be covered by the models. I will not go too much to history, but just to say that the beginning of 19th century, Richardson, father of the concept for numerical weather prediction, included as a potential parameter dust. Very early, dust was on the list of important parameters. Few examples of dust impacts. Dust-ocean interaction. As you can see, let me see if I have pointer. Maybe here, no. Anyway, on the top, there is a scheme how dust, which is emitted into the atmosphere and carrying, for example, iron, mineral, goes through different processes like affected by cloud, by sun radiation, by deposition, and so on, comes into the ocean, and it happens that iron oxide is one of key elements, mineral elements, for the living creatures in the ocean. And these are some examples of that. I would like to refer to a recent study of Rodriguez, colleagues from Spain, who published a paper which shows strict or very visible coordination of dust pattern over the Atlantic and tuna fish movement toward this pattern, which is basically source of food indirectly for this kind of fish. So definitely there is a reason to think about also on this kind of study. On a longer term, for fishery industry, I'm sure that would be they would be interested in for kind of outcome of that one. Another thing about the nutrition of the ocean, I have to mention one of our studies where we included absolutely the whole cyclus of iron transformation to the soluble solution deposited into the ocean. where a living creature really can use it as a food. Dust, weather, and climate interactions. Again, I will just go only through examples, some examples. One of studies within our community was the impact of dust to radiation. And on the top, you can see for some particular strong dust event coming from North Africa, there was a cooling of the surface temperature by about 5 degrees. This could be more or less depending on the strength of the dust process, but definitely this indicates that this should be one of the key elements to be included into global dust models, since the impact on temperature means many other things as a consequence. The other, what I would like to mention, and that's not the whole list, but I think this is quite an interesting thing, that dust particles represent definitely ideal agent for cold cloud nucleation. So, when you transfer this information into some practical things, this means that in your model, like in this example here, you can add another component, not only transported dust, but also creating new clouds because of the dust presence. And these are some examples of daily forecasts. Some of our centers are able to do this, which, well, it could look like a scientific interesting thing, but later on I will show how some important impacts could result from this effect of creation of cold clouds. Dust health. Few examples for that. Dust and meningitis. This is not a finalized study in our scientific community, but definitely there is a strong correlation of seasonal appearance of dust in the Central Africa and meningitis, which appears at about the same places with the same intensity depending on the presence of dust. There are different theories why this is so. I will not go into details except to mention one of the studies of colleague Thompson, who means that once again iron in dust and damages of the lungs could be one of the important reasons. I mean, iron oxide once again could be trigger for this kind of infection. So there is quite a lot of room to this kind of things to be studied. And of course, this is seasonal thing related indirectly into with the climate. Okay, I'm instructed to speed up now. I will try to do my best. Valley fever, and maybe a colleague who is coming soon, Daniel Tong, will say a bit more. Once again, this is the illness in the southern part of the States and Mexico. And once again, mineralogy is one of the key, how to say, impacting factors to generate this kind of illness. Another Daniel Tong map for number of, how to say, dust effects on health and safety in different ways. And I like very much this graphical presentation, this done for the States, but we are thinking within SDS was to broad this activity at the global level with the same style of these icons for different impacts. Can I have 1 minute more? Okay, because I like this slide as well. Okay, there are two aviation catastrophes. Air France 2009, Algeria 2014. In both cases, this was really a big loss of people. both flights routes were characterized with a strong icing. So what we did in one moment, we rerun our dust model. We included ice nucleation with the dust, and then on the left, right down, we showed in a Nature publication there is nothing but strong jump at the location and height of both flights, which doesn't prove still anything concretely, but indicates that this could be icing and the dust could be the cause of such events. Here I will stop. I have probably a few more slides, but I don't like to destroy the scheme.
Thank you very much, and sorry for the time limitation. And please discuss with Nichiko-san after this session. And then I'd like to move the final presentation of this session. The presenter is Dr. Andrea Cutter from World Bank. The title is Economic Growth is that represent SDS at regional or local scales. Push this button.
Very good. Okay. Hello, everybody. I'm very glad to be here, and I really thank the organizers for inviting the World Bank to this event. You probably wouldn't think that we would be here for a very science-oriented discussion, but we are actually using your science in presenting and preparing projects we have with a lot of countries all over the world, right? So we are, as World Bank, a global institution, a development bank, so we have a lot of client countries that come to us for several economic developments, including sustainable land management, agriculture, health, energy, transport, you name it, we have it all in our portfolio. So I would like to talk from a different standpoint on sun and dust storms. So many things you have talked about this morning, I look at the same thing, but I was requested to look more from an economic damage and loss point of view. Because all these impacts, these negative impacts you have mentioned, have actually a huge impact on the economy of the countries affected by it. So we look at some facts, then we will look at the sectors, and we have already discussed quite a bit. Then the definition we use to establish economic impacts, some examples, and then I think I will skip the SDS pattern in the Arabian Peninsula because, I mean, you have discussed that quite nicely already. And then I provide you with some few examples what the World Bank is doing with countries to actually address or support them to combat sand and dust storms. So we have heard it's a global phenomenon, right? And we also know that 25% is originating from human activities. The rest is more a natural factor, right? The human activities we have heard, deforestation, forest degradation, land degradation, and so on. We have about 32 million square kilometers of land susceptible to wind erosions, about the size, the double size of Russia, just to give you an idea how big that is, and 17 million square kilometers highly and very highly susceptible. Each year, we have an estimated of 2 billion tons of dust raised into the atmosphere. 1/4 of this reaches the oceans with positive and negative impacts. And as we have heard, the economy, society, and nature are negatively impacted, right? We have some positive impacts too, but the negative impacts really affect the economic sectors in countries with severe damage and losses. We have heard a lot about the health impacts, right? So this includes not only respiratory illnesses, but actually mortality. I think we have heard about this. And here the first big data, global welfare losses from premature mortality at large are increasing to now 3.6 trillion, and it's probably now much, much more because the data is from 2013, right? So these are big numbers, and I think governments need to take this into account in their decision-making process. And we have seen also soil, water, biodiversity are impacted as well. So the sectors we have heard this morning already affects the health sector, transport sector, agricultural sector, infrastructure, energy, even the tourism sector, and biodiversity, right? So there are probably some other sectors also affected, but these are the main sectors where we have noted significant impacts. So, and why is this so important, right? So a country government usually has a big budget, national budget, discussed through different ministries, and then of course discussed with the Ministry of Finance, Ministry of Planning. So if a line ministry can actually say, we have this need, and our costs of inactions are this and this, then it's a much easier dialogue with the Ministry of Finance or Ministry of Planning, because that's the way they talk, that's their language, and I think we need to translate the scientific language into the language of policymakers so that they understand why they have to shift, for instance, budget allocations. So the economic impacts from SDS, basically it's a two-way stream. The first is damage, so that's basically the impact on the asset itself, right? So that's, for instance, impacted livestock, dead or affected crops, crop failure. Somebody talked about solar panels this morning. Some of them really break. Car repairs, replacements due to accidents, but also people, and we know they are not replaceable, right? So put a number on mortality is very difficult, right? But I think we need to cover this under damage. Under losses, this is the change in economic flows. So it's not only does the livestock is dead, but the herders are losing their revenue over months or years, right? Some ecosystem services, in order to repair those, it's highly costly, and it takes often 10, 15 years, for instance, to really restore an ecosystem. So that is loss of services these ecosystems provide, and that is actually a dollar figure as well. And then, of course, you have also increased operating costs. I mean, you have seen cleaning solar panels, right, or cleaning roads, or cleaning other infrastructure. So these two combined is actually the economic impact of sand and dust storms. So here's some examples of economic impact of sand and dust storms. In China, economic losses averages about $6.5 billion per year. Right? That's a huge number. I think somebody mentioned already the 2021 event. So here we had cancellation of more than 400 flights per day, right? And Beijing's air quality index, which is normally 80, was about 999, having, of course, huge impact on the health of people, right? So many went to the hospital unable to work, right? So again, revenue loss, but also productivity loss. Mongolia, 37.8 million in losses to the economy, which would be about 0.27 of the national GDP, right? Productivity loss, right? 1.5 to 24%, depending on the strength of the event. And also here in the 2021 event, these sandstorms killed about 1.6 million livestock, right? So to replace the livestock and then to take care of the lost revenues was for many of these herders really, really, really difficult. And some probably didn't make it, moved then to cities, and because they had no income anymore from their actual activities. For the region of the Middle East and Northern Africa, our economists in the World Bank, they they estimated an annual loss of about $150 billion. So over 2.5% of the GDP of most of the countries in the region. Right? And here also the welfare loss from particulate matter is 2.5, or about $141 billion. I mean, these are huge numbers, right? And if we understand this is really a loss for a country, for the economy, for development of a country, it is really important that decision makers understand the costs of inaction. Another example is, of course, you know, the Aral seabed. You probably, I mean, this is one of the biggest man-made catastrophes that happened, right? So when excessive irrigation basically killed the Aral Lake, and here we have now the sand and dust storms from the seabed, and generates annual losses of over $44 million, right? So if continued practices, if nothing is done, so you see the on-site losses of benefits average $32.6 million per year if we don't do anything, right? And also linked to this, of course, health impact and crop production losses as well. So here, just from the STS for the Arabian Peninsula, we have heard about it. What I just wanted to make the point here, and I think that came out very nicely also in the launch of the partnership, it is not a national issue alone. You can only resolve this by having collaboration across countries and regions, right? And I think that's why we have heard about the Middle East Green Initiative. I think it's a great initiative to address especially these type of land management issues in dry areas, because what we have available right now, for instance, in international funds like Global Environment Facility, is mainly geared towards tropical and subtropical countries, not towards dry countries, right? So, and then we have heard also from Kuwait, what the Kuwait Fund for Arab Economic Development is doing. So I conclude with just some examples how we as World Bank invest in combating sand and dust storms. So for us, the rationale is a trifactorial one. So it's the economy, it's society, and environment. And these three together need to be addressed. You cannot address them individually. And the approaches we take, so we look at the 25% man-made causes. There we really address it by improving land management. We have a lot of investments in sustainable land management or landscape management. And for the other areas, it's, as I think somebody said this morning, it's really by focusing on increasing resilience of the economy, society, and nature. And here just three examples. So we have, for instance, large-scale integrated landscape management in Tunisia, where we invest in forest, rangelands, and oasis. In Egypt, we get increasing requests for development of early warning systems. So we have there, for instance, one for air quality. SDS is now part of it. And then we are investing heavily in the Aral seabed to actually reduce the ability to generate sand and dust storms in that area. So, and we hope that these benefits are not only for the national people, but also for the region, because as we have seen, this whole region is really the root cause for a lot of sand and dust storms that affect other countries. So that is our work we have in many, many countries, and we look forward to continue our work with all these countries in order to resolve that problem. Thank you so much.
Thank you very much for the presentation from World Bank. And so, the time is limited, so I'd like to finish this first session. And thank you again for all the presenters, and I believe that the presentation are very, very important for combating sand and dust. And
you, Takashi-san, for the nice sharing of these sessions. I want to invite the next moderator, who is Georgi Stekonov. Right? You are moderator, yeah? In the new agenda, you appear like chairman of this session, no? Chairman, yeah. Sorry, it wasn't expected for you.
Hi, everybody. So we have to continue. Time is tight. So the next presentation is by the group, Dr. Rami Al-Farah, Qatar Environmental Energy Research Institute. And the title is Impact of Dust on Urban Air Quality and Arid Regions.
Okay, well, hello everyone. And I'll try now and take sand and dust storms and dust in general to air quality, to in urban areas, to the air we breathe in, and how this affects us, and what does it mean for air quality. I'll start with this global picture from a simulation of PM 2.5, which is one of the most important pollutants for health impacts. It's regulated internationally for areas of the world. It's dominated by different major sources. And you can see, for example, in the Amazon, in the tropical forests, it's all organics in green. And then in Europe, in China, you have the white sulfur from anthropogenic industrial emissions. And then you see blue over the oceans. And then substantially, you see the orange right in the middle, the dust belt, Saharan Africa, the Middle East. So this is very important when it comes to air quality, because this is really what dominates what we breathe in. But also the interaction between the different sources and activities in urban areas, industrial areas, means we have a lot of sources interacting. And ultimately, we breathe these mixtures in. And that's what really determines the health impacts. So in a regional context, in the Middle East, we have very fast urbanization for the last 30 years. Urbanization happened exponentially. Population increase, construction activities, industrialization, oil and gas industry, shipping, all of this happening on top of a background of natural dust. So how this pans out to us, what does this mean for air quality in this region and in other regions, is very important. How we deal with it, how we regulate it is very important. The WHO, of course, leads the way on regulating for health and guidelines for all the pollutants. PM10, PM 2.5 are regulated as standards internationally, are guidelines for health by WHO. But more recently, the WHO recognizes that the total mass alone is not sufficient potentially, or is not the only component that determines the health. We breathe in black carbon, ultrafine particles, we breathe in dust, and currently the way we regulate assumes that if you breathe in 10 micrograms of dust, it's exactly the same as you breathe in 10 micrograms of black carbon from combustion. We don't know if this is totally true. We think it's not true. We think there is more evidence that differential toxicity plays a role, or the total mixture is important. This work needs to be done. And the effect of this at source region versus receptor region is potentially very different. For us, we're very close to sources. So in the Middle East, dust at source, dust interaction with urbanization emissions at source
is potentially different to what people in Barcelona or in Southern Europe or in the Caribbean breathe in from long-range transported, diluted, and processed dust. So this is an area where metrology, atmospheric chemistry, health, and air quality all come together. And for dust, when it comes to WHO, they talk about air quality management plans, forecasting, early warning systems, which we've seen a great initiative about this morning. So this, and crucially, scientific evidence is still lacking for the health impact of dust. Epidemiological studies are being done, but not enough. We need more. But crucially, we need more exposure studies. We need cohort studies. We need to get the evidence, not only at population level, but to understand what dust does, what the interaction of dust with urbanization does at source. This is really important, and it's currently lacking, and this is what's stopping the WHO setting guidelines for these components. So when we talk about the SDS, we need to understand that, of course, SDS, these are meteorological events. They happen at certain frequency, at certain times of the year, certain number of days, but they're not there all the time. Air quality is always air quality scientists, atmospheric scientists. We need to come together and do something much better, right? We talk about dust, we talk about PM10, PM2.5, suspended TSP. I think literature is, everyone talks in their own language, but we should come together as a community and have something much better. So let me just walk you through this slide, and excuse me for all the experts here. So for air quality, we talk about PM1, PM2.5, and PM10. When I talk about dust, mineral dust, so these are the 10 microns, 2.5 microns, and 1 micron. Mineral dust typically is between 1 micron and 63 microns. And this is the Spiros and Pandis textbook definition of dust, okay? From mechanical generation of natural and man-made sources. Mechanical generation. And then you have sand. Of course, sand is above that. And sand is, close to the ground, and we understand all of this. And then for the dust itself, the mineral dust, you have silt, which is most of the dust is silt. And then you have clay, which is less than 2 micro. So it's a clay and PM2.5. So you can see the literature. And then when people talk about dust storms and dust events and SDS, PM10 or PM, mineral dust, and then you have visibility. I mean, of course, crucially, what is really transported long distance, more than 100 kilometers or so, which is really important for transboundary and for sources, is the stuff below 20 microns, right? All the larger stuff don't really make it very far. The sand doesn't make it very far. So we can see the transported, the transboundary, and the regional stuff are the stuff relevant to the PM, but we only regulate PM10 and below. You see where this is going, right? So this is really, really an issue where we need to, as a community, multiple communities, come together and do something about it. And then we only regulate PM2.5 and PM10. That's the only thing regulated. Standards and health, right? Everything else is not regulated. Everything else is early warning system is very important. So this is where my talk is going, really, right? In that direction. And then when we talk about SDS or sand, then visibility comes in. So observers at airports, visibility is the measure for dust storms, right? And then visibility, there's a whole new world there. What is, there's no definition. Below 1,000 is severe dust storms, but then you have thick fog and thick haze. Below 5,000 is moderate and strong dust events, but also you have haze and you have fog. You cannot, from automatic measure, without an observer making a note, manually, you cannot distinguish, right? And then above 10,000, probably clear conditions, probably, right? So all of this is important information, but it all exists in its own separate silo, right? So this is a call for us to get together and maybe write something up and start communicating. I tried to explain this to a policymaker last week. This is why I made this slide last night, because I was trying to explain this to a policymaker, a minister. What is dust? What is PM? What do we do? What do we regulate? And this is my summary. You cannot explain this to a policymaker easily, right? So in air quality, this is what we really focus on. PM1, PM2.5, and PM10. This is what's regulated, the first two, not the PM1, but there's a lot of talk about ultrafines now for health. We know where they come from. The PM1 mostly from combustion, and the PM10 is mostly mechanical and natural, sources and also that break. And the PM2.5, the in between, that's really a mixed source. So the way we do this to understand what does this mean for equality in an arid urban region, in an arid environment, we study this at very high detail with a network of research stations across Doha. So we focus on Doha because this is where 90% of the population live. We try and understand the scale here. You can see the small, the whole Qatar, but this is the box over Doha, which is really 5% urbanized area of the whole country. So it's very small, but roses show you the prevailing wind. 2/3 of the time, it's northwesterly, so our stations are aligned this way to capture it. And then we have to bring in, some hardcore equipment, research equipment. Normal monitoring is not enough. So regulatory pollutant does not really answer the question. It gives you mass, and that's it. To understand the details, you need research grade. So we have the only super site currently in the region, and the red store in an urban region, urban background site. We have a research super site. And when I say a super site, it's a standard air quality research station enhanced by top state-of-the-art research equipment to allow you to understand chemical composition, elemental composition in real time, and add as much information about atmospheric chemistry, meteorology, so you really can understand what are the sources, what is the dynamic, what's happening, and that then allows you to understand the impact of dust and sandstorm on air quality. We've just summarized that for 3 locations, for a regional background location, for an urban location, urban background locations. We define a methodology, I'm not going to go through the technicality now, to define sand and dust storm periods based on our data, anthropogenic pollution periods where we have dominant anthropogenic pollution, and normal days outside anthropogenic pollution episodes, and outside SDS episodes. And what you see is SDS periods about 8% of the time maximum, so consistent with the literature review, 8% of Qatar. So in the regional background, it's 9%. The same, our method shows exactly what the literature shows. In the middle of the city, because you have more losses of PM10, it's lower. And then anthropogenic pollution in the city is up to 13% or 8% in the region, in the city. But 90%, 80% of the time, we're not in a SDS. We're not in a major anthropogenic pollution episode. We're on normal days, What does this mean? This is what we breathe in most of the time, where we don't have SDS early warning alerts. There will be no alert during the 80% of the time it's blue, right? Because it's not SDS. And that's what we breathe in. What does this mean for dust? Do we get dust outside SDS in an area like this? So here is our diurnal patterns of PM10 and PM2.5 in a regional background and an urban. In the top ones is PM2.5, regional background in the middle of country in the desert, urban in the city. And what you see immediately is there's a very high background of PM2.5, around 40 or 30 micrograms per cubic meter. And you see the morning rush hour, just about. And then for the PM10, the same thing, very high background, above 100 micrograms. This is the bulk of the time. This is 2 years of data. So this is 80% of this time we're not in SDS, which means dust remains suspended. The dust is in the background. We breathe it in. It's mixed with everything in times where we're not really being warned or alerted to it. And then if we look at the seasonality, this is really, the same plots, the same PM2.5, you see it's exactly the same. You get an increase in PM2.5 and PM10 when you expect dust storms to be more dominant from April to October. So it goes up, which is very consistent with 2 things. Consistent with dust storms or dust episodes, more frequent shamal wind, but also this is where a lot of the chemistry happens, atmospheric chemistry. VOCs, oxidation, in the summer with more intense photochemistry, you have formation of secondary aerosols, secondary inorganic and secondary organic aerosol, potentially deposited on the dust, mixing with the dust. The seasonality of both coincide. So this alone does not tell us the full story. We need the full chemical composition. We need to know what are the sources determining the PM2.5 and the PM10. And this is an example of PM10 on the left. In December, January, in the winter, dust, yellow and brown. These are 2 different types of dust we can separate with our online measurements. One dominated by calcium, one dominated by silica and aluminum. They come from different directions. The shamal wind ones and the westerly ones. And they are chemically different. But in winter, for PM10, they're about 20% of the mass. 80% is man-made pollution. As we go towards spring, March, April, dust is 50%. And if we will continue now with our data analysis into the summer, we will get a lot more dust probably and secondary pollution. For PM2.5, 95% of the time in winter, there's no dust. It's man-made pollution. And it becomes 30%. So for PM2.5, for health, only 30% is dust on average. So the region has very important sources of man-made pollution, mostly lead, sulfate, and ammonium. These are our secondary pollution from SO2 emissions that's been oxidized, transported, and became secondary inorganic. This is regional sources. This is all from emissions in the Gulf, shipping, industry, leading to SO2. This is very big. In Europe, these plots will be dominated in the US as well by green, by organics, from forests. In our case, sulfate, ammonium is very important. So the last thing is I cannot talk about air quality and not talk about health, because we do air quality because of health. And because urban areas, people, and I think in this region, we need to continue to do more at source region. A lot of work has been done at receptor areas, and some work has been done by our colleagues at Kessler on epidemiology. We need to do more to understand the interaction between dust and anthropogenic emissions. Dust alone can be a carrier for biological materials. It is known to be irritant and it causes allergies. But what does happen to a dust when it interacts and modifies its properties? We need to collect more in high quality environmental data and health records, connect them together in a more detailed studies. But we need very crucially to conduct real exposure studies, cohort studies, toxicology studies in this region. And I think this is a regional mandate for all of us. We really should do it together. I'm trying to do this in Qatar, but I think all of us should do it, and we should work together to do this at the regional scale. We face exactly the same challenges. We all have the dust background. We all have the industry. The picture I showed you there, I will not be surprised if it's shown to be the same in many other cities in the region. This is the only super site we have currently. I hope we make more super sites in the region to get this picture regionally so we can all work together. Ultimately, mitigating this requires regional collaboration. No country alone can do this alone, for dust and for man-made pollution. And I thank my colleagues, and I thank you all for your help.
Thank you, Dr. Rami. Very impressive talk. So we really have to know much more about dust. So, and interaction of dust for other pollutions. Regarding super sites, there were several campaigns that were organized by Max Planck Institute for Chemistry. It is Aqaba campaign. It was ship campaigns. And they also did dust specialization. They used mass spectrometers, and they confirmed this conclusion that there is a lot of anthropogenic aerosol in the pollution. And from one side, it is bad news, but from other side, it means it is controllable. So regulations could be applied to improve the situation. Thanks very much. And the next talk, but Dr. Takahashi-san, and he will be talking about impact of vegetation on sandstorms. Whatever you like more.
Thank you very much. And my name is Takashimaki from Meteorological Research Institute. And thank you again for National Center of Meteorology of Saudi Arabia to host this very important event. And today I'd like to show you the importance of the vegetation in sand and dust storms. And my talk consists of 5 parts. The first one is the sand and dust storm current status. The next, this slide is not the theme of my presentation. Could you change the slide? This slide is preparing for the moderator of this first session. And this map shows the dust source map from UNCCD, and below is the sand and dust storm simulation by our Earth system model. And this orange color shows the dust storm, mineral dust aerosol concentrations by our system model simulation. I uploaded 2 presentation files, and could you exchange my presentation file? Thank you. This is the slide. Okay, I'd like to show you the importance of vegetation. Sorry. Slide is not, sorry. Sorry, I'd like to show about, try to introduce the importance of vegetation. And this slide shows the outline of our system model. We now developing a system model named MRI ESM2. This model consists of many components: atmosphere, ocean, and also vegetation, and land surface process, and sea ice, and so on. And below figure shows the global warming impact in Gobi Desert. Dust emission is increased in early March and early spring and late autumn. This is the another paper, and sorry, and sorry, and this is the SDS bus structure. Now we have 4 nodes: ASEAN, and NAME, Pan American, and GCC. And could you change my and sorry, I'd like to try to talk. First, I'd like to show you the vegetation map and the sand and dust storm slope map. These 2 figures shows the strong correlation map. These 2 figures shows the strong correlation. Of course, the sand and dust storm arises when the strong wind blows the arid and semi-arid area. And so the blows the arid and semi-arid area. And so the vegetation is very important. And now we are developing our system model in which the many components are included, and so on. And I prepared the correlation map between the dust emission amount and vegetation LIAI index. And many regions shows the some correlation between dust emission amount and vegetation. Of course, the sand and dust storm emitted in the arid area, and when the strong winds blows to this area. So the most important factor is the wind speed, friction velocity. But some areas shows some correlation between the vegetation and dust emission amount. And of course, in Asian region, and dust emission amount correlate the snow depth. But this correlation is negative. When there are much snow depth, the dust emission are suppressed. And I have prepared the one slide for the dead leaf effect. This insisted that the dead leaf is a very important factor in considering dust emission storm in Asia. And I prepared the presentation file about the Moody's and LAI trend and from the paper.
Screen very quickly. If you can send again the slides to the organizers, this will be welcome. And we will ask to the next speaker, please, if you can come with us and do your presentation now. Meanwhile, we are figuring out how to recover the presentation of Takashi-san. Really sorry for the interruption.
Good afternoon. About the monitoring and modeling of dust and sandstorm in Saudi Arabia using geospatial techniques. I need to talk a little bit about dust storm. What is about dust storm? It is about ornate override region with fine granited soil. And this is fine organated is lofted about airborne when exposed to a strong wind. And the sandstorm, it is about Ukiah and desert region with low sand, and also oven and dunes. Similar to the dust storm, but about the localities, about the size, the particle, it is different, like become as big size. And sandstorm, it is classified in term formation in a class of 3 categories. The sandstorm and coming from thunderstorm, and also coming from depression and cold front, and also come about local influence, including local wind. The aim of this work investigate the climate data for 29 surface stations during the period 2015 to 2023. In addition, I used Moody's satellite image of 5 dust conditions during the period from 2011 until 2018 to indicate the frequency of occurrence of dust and sandstorm. And I used the meteorological condition and general feature pattern on synoptic chart. And here I need to talk a little bit about sand and dust storm through the city in eastern region in March in 2021, lead to completed lack of visibility and turn. I need to apply this video here. I need to show you the video how can become the sand. And become this is an eastern region to cover the whole the biggest area here and reduce the visibility and become the sky like as red. And I need to show you what I use the data and methodology for this study. I exerting the measuring the dust and sandstorm over Saudi Arabia beside a 29 image from Equa and Terra satellite Moody's, moderating resolution, imaging spectral radiometer. It is include 36 spectral bands, range from 0.4 to 14.4 micrometer by model building. Also, the quantitative analysis, also the quantitative analysis about the data number of days and hours of occurrence dust and sandstorm issued by the National Center of Meteorology for the period from for 2015 to 2023, which is include 29 meteorological stations to do this analysis for this study. Also, we use here a base map for created and layer for geographical feature using feature database to use the methodology interpolation method in ArcGIS Pro by the tool IDW. Here, I need to talk a little bit about the procedure for extracting dust from Moody's. We obtaining the Moody's satellite image of 5 dust conditions from NASA Earth data website. This is image processing determined in the thermal band from 31 and 32 using the Moody swatch tool and converted to digital format. And after that, we convert digital number and the spectral radiation value and also application a Planck's equation for extract B2 brightens temperature. And the subtract the value of band 30 Raman method. Combining the air depression, trigger, sand and dust storm, intensity of the excitement dependence on dynamic of jet stream, and area of atmospheric pressure distribution, region, and also region for topography and the gradient of atmospheric pressure and temperature gradient. From the most important factor, arid and semi-arid land that characterized by an average annual rain of 500 millimeter and increased rate of wind speed and distribution of atmospheric pressure and the sand dune, which area is estimated at 28% of area of Saudi Arabia. And here I need to show you what I get the result. By extracting the data for dust and sandstorm from the Moody's satellite, according to the result to a study related to acid in summer and fall as compared in present. The Arabian Peninsula would have the most frequent dust emission flags. And also this study will focus on several dust spread over the long distance and severity their negative effect and orbit and belowing according to the comet of the nominating distinctive climate condition in Saudi Arabia. Right now I need to talk a little bit about different type of this name of the dust and sandstorm. I choose first one about the Rhea fish dust condition. This first dust event, this study was monitoring from the Terra satellite in March 2011 in the time in morning, starting from the flood plant between the Dijla River and Equatorial River in Iraq, extended within the Kingdom of Saudi Arabia with dust mist with area in 2011 almost kilometer square. The dust density indicated that the dust contained increased phosphorus, then decreased after a day which storm travel distance 2,000 kilometers and affected the central and eastern region. And according to the classification, the density of the dust was heaviest and red color and range from 0.5 to 1.6 grams meters square. And the second condition, the dark dust condition, It is originated for Al-Hammad and Nifada and Nafud al-Kabir ring in North Saudi Arabia. Its movement was recorded by the Tira satellite in the 1st April in 2015 with an area cover of almost 200 kilometers square, comparing with northeast and toward and the southeast. And also that started in the next date, it was monitoring in the Equa 948 kilometers square with an cross section of approximately 2,000 kilometers. And this condition take of the characters darkness, this is due to density of the dust, and the classification standard indicate that the large area and the dust density range from 0.049 to 0.91 and shut down and began to fade away. And it was spotted again in May in 2017, and it was similar and covering most of the north and western and central and southeastern region of Saudi Arabia. 1,000 kilometers square. This condition is characterized by slow movement and take 3 days to across Saudi Arabia. We cannot cover it by the station.
Very good. Thank you. So the next talk will be remote talk. About successful, do you have remote talk? Next talk by Tarek Sadek from Esqua. Successful experience in dust storm management. This talk supposed to be presented remotely. No. If they have his talk. Daniel.
Can you see the screen?
Daniel.
Huh? Can you hear me?
It is
Hello?
on, yes.
Okay, can you hear me, please?
Go ahead.
Thanks very much. I will just present quickly ISPA work on sand and dust storm impacts and analysis in the Mashriq region, making use of climate projections to link with seasonal forecasting to understand more how frequency of sand and dust storm could change as far as intensity with the climate trends. Screen is not moving. I will, yes. So as you are all aware, we have a belt of sand and dust storms starting from West Africa, Sahara, to Arab Peninsula, as we saw in the previous presentation and Dr. Zakai's one. That we need to look at the drivers for these events and try to understand more the climate projections in the region, given that most of the emissions are due to human impacts, which counts like 30% of contribution in the MENA region. So if we look at the impacts, we are all aware that the Arab region and MENA region is affected due to sand and dust storm. They have severe impacts on health, agriculture, transportation, economy, and ecosystem. So we need to work on these impacts to alert decision makers how important looking at sand and dust storm impacts and linking them to the economic development. And this idea of how we can highlight these impacts, like looking at health, our colleagues WHO are doing work to try to link the source to impact, how to see the impact of sand and dust storm on injuries, casualties in the hospital, so how we can relate to different reasons, children, the elderly, and individuals with pre-existing respiratory diseases. And it also affects animals and livestock, injuries, decreased productivities, in the livestock. So all of these would have impact on economy of the countries. Agricultural lands are highly affected by sand and dust storm in Saudi Arabia, as my colleagues showed, and mainly we notice that wind erosion depletes the topsoil, the fertile nutrient-rich topsoil, and also dust obstructs the photosynthesis kind of properties of some plants, and it would affect productivity in general because of this, and frequent SDS accelerate degradation and making land less suitable for farming and increasing rehabilitation costs. And this is what we need to look at green belts and how to protect cities from these sand and dust storm and their impacts on different sectors. Also crop damage, as I mentioned, and we need to look at the livelihood of farmers at small scale and how we can look at integrated approaches, looking at water, energy, food nexus to try to combat the effect of sand and dust storm, especially on cash crops. Transportation, it's very important to look at transportation in terms of visibility on the roads. And also we had some work with ECE, Economic Commission for Europe, when they had heat waves during the last summer. They contacted us to know how we are working with these heat waves. They were highly affected in the operation of the railway network. So they had great losses because of these destruction of the operation of the highways, and we started to work together on how to use our climate projections in developing parameters for the future on dealing with codes for transportation, for buildings, and so on, for different extreme events due to climate. So we can see that dust can reduce traction, increase skidding risk, and also frequent delays, cancellation, as you notice with airport, and also SDS disrupt supply chains, raise maintenance cost, and impact industries like oil and shipping. So we need to translate this to economic values or dollar values. And as we notice that there are very few studies that exactly estimate the costing, economic costing for impacts of sand and dust storm, and we need to work more on this. We have some figures estimated by the World Bank, by Kuwait research journals, when they looked at oil industry, how it was affected by around $9 million over the last 8 years due to sand and dust storm. So we need to look at what kind of mitigation strategies needed. We need to alert decision makers with all these economic figures that are affecting GDP and overall economy, macroeconomic variables of the countries in our region. So how we can do the diagnosis and how we can identify hotspots. My colleague Zakiya spoke about MODIS. We used also MODIS of NASA to analyze all major storm events. It's open source information, as you can see here, the link, and we can see in this slide the red boxes at the right where we had the key or major storms analyzed, and we picked like 13 intense storms to look at how to derive the dust index based on different reflectance from different bands. We do the mathematical equations. Experts in the forecasting are aware of that in the meteorological offices. And finally, we can look at the left side with the true color images of the different sandstorms, while here we can see in 2 days we can actually delineate those using the sand index methodology of MODIS, so you can simply know where the sand and dust storm happened, how it moved, and you can monitor different storms as well, so we can know where the hotspots are exactly in the Arab Peninsula by just mapping those kind of highly and moderately affected areas in red and orange colors, and looking at different seasons, as my colleagues explained, we can define the direction, the hotspots, and we can work on the ground on dealing with these hotspots as Iraq and Kuwait are doing in their joint project with UN Habitat. And also we can decide on specific areas that are affected by sand and dust storm due to desertification. We can decide on where we can plant trees or green belts for different areas of these hotspots, as we are doing with the Middle East Green Initiative and other plantation projects. We developed a platform also to analyze these historical storm with the ones with true colors, and then with the analysis of MODIS, you can get the boundary or the border of this sand and dust storm. It's connected to the WMO online information for each storm, so you can monitor on one screen the for each storm how much was the wind speed, the visibility, so you can do correlation of different parameters to know the intensity more, to learn about, understand more the intensity and frequency of each sand and dust storm. Also, we need to look at the ground actually where we are losing water bodies, wetlands, and also different land uses and vegetation cover. Because if we look at this area in Iraq, we can notice that there's a continuous shrinkage of the water surface area by every 5 years from 1995 to 2020. There is a bit of increase in the last 10 years, a bit of improvement. But if we look at those, all this period for 25 years, we have lost 1900 square kilometer of water surface area and wetlands, which are mainly marked in red here color. So we need really to look at rehabilitation of these areas and to see how environmental parameters are affecting the occurrence of sand and dust storms. And again, these are different lakes in Iraq, Razaza. Using just Google Earth images, you can see how the water body area is changing with time, and this could cause all this area, which is bed with fine sand, which is exposed to be carried out during with a strong wind to form those kind of sand and dust storm which travel for thousands of kilometers. So what are we doing now to solve this and to work together? Actually, we, ESCWA and ESCAP, will be co-leading with other, of course, contribution from all other organizations, WMO, UNDP, UN Habitat, the UN Coalition on Combating Sand and Dust Storm, Actually, FAO did a great job during the last 4 years in leading this coalition. We have organized joint inter-regional webinars. We need countries to talk together in West Asia, Central Asia, as well, like Saudi Arabia, Kuwait, Iraq, Iran, Afghanistan, Turkmenistan. So we had those countries talking together to decide on how to cooperate, how to share knowledge on the regional and the inter-regional level. And we, through our work in the coming 2 years, we will try to operationalize the new decision by the General Assembly to establish a decade on combating sand and dust storm for the coming 10 years. So we have a lot of work to do on sand and dust storm. We are working also with Saudi Arabia on capacity building for workshops on analysis and modeling sand and dust storm. We did one workshop last year, and we will do two this year with the center, WMO Center for Sand and Dust Storm in Jeddah, as well under the Meteorological Center. So we need to emphasize a multi-sectoral approach that integrate SDS into broader socio-economic and development agenda. The costing and also economic impacts is very important to work and to alert decision makers about to act together. Also, we will do a series of inter-regional dialogues between Mashriq and Southwest Asia region, and we will begin this next week. I didn't come this week, but I will be in Riyadh next week. We will run two sessions, one for the UN coalition on the 10th, and another one to establish these or to launch these inter-regional dialogues between the two regions of West Asia and Central and Southwest Asia. So it's on the 11th, and you are all invited to these sessions, which I will share with Dr. Jaman and Dr. Zakiya in the coming 2 days. Thank you for your kind attention.
Thank you. The audience, do you have any questions to Tarek? Okay. Thanks very much, Tarek.
Thank you.
So we stop now. We have two talks in the session. Okay. So very short lunch. Try to do it for 45 minutes. So after lunch, we will have talk Dr. Tahashi and Daniel and finish this session then. Okay? Thank you very much for participation. have your attention, please? So we restart the session. So the rest of the session will be in following order. First will be Daniel. Yeah, it's working. And after then, Takashi. So finally we'll get his presentation on. So Daniel, please. Professor Daniel Tong will give a talk about global trends of dust aerosols and impact on society.
Hi, good afternoon. Can you hear me okay? Hi, this is my talk. It's actually on behalf of a large group of people. I'm a professor at George Mason University, but also I wear the hat of the chair of WMO SDS Global Steering Committee. So this is really a coordinated work by this SDS Global Group. Hi. So we have, my colleagues already set the stage, so I'm just cut the cheese, go to the results. This is a large group effort. We are putting 4 centers together, including NASA, the ECMWF, which is the European Center for Middle Range Weather Forecasting, and the US Naval Research Laboratory, Peng is here. We have the Finnish Meteorological Organization. So the 4 centers are doing the long-term dust reanalysis. Our goal here is trying to build a community consensus, which is have an authoritative data set that represents the long-term trend of global dust. We call it also authoritative. It's not because it's WMO, it's because the centers are doing a lot of hard work, and we try to build on top of their good work. So interestingly, we discussed what is dust. What do you mean dust? So here, what we choose is 3 parameters represent dust. One is dust AOD, which is the aerosol optical depth. It's the total column of what you see from the space. The second one is dust PM2.5. It's what you can inhale deep into your lungs. And then also PM10, that's also inhalable. So this is the global data set. You see that we have 2 data sets. One is ensemble mean. Basically, it's the average of the 4 data sets. And also we have ensemble median, which is the center value among the groups. So this data set is at 0.1 degree from 2003, day 1 of 2003 to 2022. So the data is available. If anybody is interested in getting the data for your country, feel free to contact me or anybody, or Sarah here. Okay, so what did we see from this global data set? That's only one message. From the first 5 years compared to the recent 5 years, we see 31% increase of the number of people exposed to very high level of dust, which is higher than 45 microgram per cubic meter, which is really interesting. You look at here, in Africa, you see a lot of countries seeing a decrease of exposure days. That's because the dust sources in Africa are getting weaker. That's because of climate change in this region is getting more rainfalls. And if you look at the Middle East, we have a mixed picture that most of the countries in Middle East actually are seeing an increase of dust in the past 20 years. So this map has already been published earlier this year in the Lancet Countdown. You can see the work by Maria et al. You are able to see this work. So what does it mean to the global community if you see a dust increase in your region? What does it mean for health? What does it mean for economy? Right, so that's the work we are doing. I will use the United States as an example because we have accumulated a lot of data sets in the States. One thing that we find in the United States is dust storm is not just soil particles, right? Within the dust storm is a soup. Anything of the right size, appeared at the right time, can be part of the dust storm. So one thing unique in the Pan-American region is a fungus called coccidioides. This fungus been living in the soil peacefully with human beings for millions of years. But once the soil is disturbed or be carried by dust storms, the fungus can be inhaled by human or animals. In a natural environment, the fungus can grow a little bit and break down and go back to sleep. But once inhaled by humans, you have unlimited supply of moist and nutrient. So within 2 weeks, you can convert your lungs into a big mushroom because the fungus just grow like that. The spores of the fungus is also very small, can flow with the blood. So this is a real story. 2019, I was in Arizona for a conference. I talked to the Uber driver who dropped me at the airport. I asked him, do you know this fungus? Do you know the disease called valley fever? He said, oh yes, my daughter just recovered from that disease. But the fungus went to her brain, wiped out her part of memory, that she had to retrain herself for the same old job she was having before she was sick. So this is a very growth. You can see the fungus can grow from any part of your body. So this is a valley fever burden in the United States according to the CDC, which is the Centers for Disease Control and Prevention. Most of the, we only have data in the United States. This disease actually been reported across Central America and South America, but we just don't have statistics here. So I'm using the states. Most of it come from Arizona. That's the state I visit. And then also California, the states catch up. So you are seeing the recent increases mostly from California. So the question is for the dust people like us, the fungus living in the soil, right? You have more dust storms where you have more valley fever infection. So we put the places we detect the dust storm, the red circles here are the locations we detect the dust. The bigger the pie is, there are more frequent dust storms. And you can see that in the southwestern United States, the same states, you have a lot of dust storms. You also see a higher rates of valley fever infection. We actually dive into Arizona to look at the two endemic zones. That's the Phoenix city and also the Tucson. We find that the monitors, only the monitors are getting closer to the cities. They are more relevant. The correlation between the dust storm and valley fever infection are stronger. So this is an evidence that we try to establish between the dust storms and the infection disease of valley fever. The bad news is that's another study 2 years after we published our work. Is that they did a model simulation, and they found right now this is where we have a lot of dust, valley fever cases in the southwestern United States. But by the end of this century, this endemic zone is going to be expanded to the entire western United States. Where it's continue to move to the eastern United States, will be transferred to Europe. We do not know, because dust can travel thousands of miles. So the other problem we have with dust storm is transportation safety. I want to do a quick survey here. In our audience, how many of you have ever driven into a dust storm? Raise your hand. Oh, okay. So not too many people. I did not either. So what do you do when you drive into a dust storm? Is there any like a traditional way to handle that? Okay. Okay, so that's interesting. So this is at the bottom is a picture I took when on my field trip to Arizona. I see a lot of roadside memories. That's where people got killed by dust storms, and they try to set a place to memorize the location their relatives got killed or friends got killed. And that's actually a kind of myth in many countries, I think, how many people got killed by dust storms on highways. So in the US, for example, they have this official statistics called National Hazard Statistics. They put a 0 for the people killed by dust storms. But we know that's not true, right? Because if you are a dust alert like me, you get a lot of friends send you messages, hey, there's a dust storm happened, 7 people killed. And then you go back to see the national statistics, it doesn't match, right? So that's why I want to figure out what's wrong with our national statistics. There's 0 people died, but they can have 1 accident killed 6 people. So what I did is I took two data sets. One is called the storm events data set. Basically, it's the weather spotters trying to report these extreme events, and they send a message to the National Park Service. The other one is the police accident report. So every time you have people killed and have a car accident, the police will be there and file a report. Right, so I put the three data sets together. The red is the official report that the National Weather Service put it out. And the purple one is the weather spotters report. And then the blue one is the police report. I think the police action report is more reliable because that's their job to document the weather conditions and what caused the accident. And we found that the wind balloon dust actually killed 20 times more people than what previously reported. It's kind of big surprise. I actually ended up doing a lot of interviews, people trying to understand why we have so many people killed by dust storm, what went wrong. So there are two problems with the national statistics. One is people don't have complete information. Like you have to go to the police report to figure it out. The second one is they put dust events as a high wind events, like weather people think everything is weather, right? But dust events is not a weather event for three reasons. One is they add dust into the air to change the visibility, right? Because people cannot see, the people start to panic and they make wrong decisions. That's why it causes many mistakes. The other problem is the powder, the dust put on the surface, actually it's like a slow, you need to take a longer time to brake, to stop your vehicle, right? If you do not recognize that, you get a car crash. So for that reason, I think a dust should be listed separately as a different event than high wind event. So where did we see those people killed by dust storm in the United States? It's very surprising. I could not believe my eyes when I first have this map, that dust can kill people across the entire country, even the places we have a lot of forests that have no desert, right? Because dust storm, you only need three elements to create a dust storm. You need a barren land, and not covered by anything. You need a land to be dry. You need a high wind. So you can create a dust storm. People living here, you are very familiar with this, can create a dust storm anywhere. So this is why we're seeing a lot of dust storms cause the car crashes. And some of places like northwestern United States, this is the state of Washington, is caused in the cropland. So cropland is a seasonal dust source. We have some hot spots, like between Phoenix and Tucson, where they also have a lot of valley fever infection. They have this 10 miles, that is 10 miles in the United States. So within the 10 miles, about 16 kilometers, they have hundreds of car accidents just within that corridor. So this is called, that is 10 miles. And then also Noblesburg Playa, they have a lot of high impact. They have 5 or 7 people killed in one accident. So we try to quantify the economic impact of dust storms, and I was able to only cover valley fever and transportation, but there's many others, like agriculture, we mentioned a lot, household, solar energy, renewable energy, and spread of pathogens. We came up with a total annual cost is $154 billion, which is comparable to the entire Middle East and North Africa case showed by Andrea earlier. So I think this is a time for us to redo this kind of accounting and to figure out what is the real cost for our society. And if you compare the dust to other weather conditions, that dust actually is higher, the cost of dust is higher than severe storms, hurricanes, wildfires. Yeah, so that obviously even for the United States, where dust is not considered as a major environment problem, we still have a very high socioeconomic cost. So we have done this work over the US, but it's our hope, as Nichiko mentioned earlier today, we want to do it in other countries, and we would like to call for collaboration with WMO, SDS was, to work on this project. We have the data for the entire nation, and we have the methodology. So if you are willing to work on your own country or own regions, we'll be very happy to support you on that. And this is the map you have seen earlier, and eventually we want to have the cost, socioeconomic cost assessment for the entire nation, for the entire world. So with that, I want to wrap up. Climate change caused 30% higher number of people exposed to dangerously dust levels, and then this have a huge impact on the society. We only have like one country done this, but I think it's a time for us to rethink about doing this to other regions. Yeah, thank you very much for your attention.
Thank you, Daniel. It's very important to put dollar number on the events. Regarding the impact on health, you mentioned that so in Middle East, the optical depth and concentration of dust increased during recent years. But there is another factor. So population in Saudi Arabia, for example, starting from 30s, increased 10 times. So much more people are exposed to this event. And when we talk about health effect, we have to weight it by population, by density of population. And this kind of works both in the same direction, increase of concentration and population.
Yeah, that's a good point. Actually, in our study, we did a population weighted, so that increase was population weighted. Where, and if you added a population growth, that the impact is even bigger. It's a compound impact.
Okay. More questions? Okay, let's move forward. Thanks very much. Our next speaker, so from NCM, Dr. Dr. Marwan Al-Khalal, and he will be talking about thermal continentality in Saudi Arabia. Please.
Good afternoon, everybody. My name is Marwan Al-Saqqal from National Center for Meteorology in Jeddah. My talk today is about a new approach to the thermal continentality in Saudi Arabia. I'll start with defining the continentality and go ahead on other tasks. Continentality is a climatic condition which has characteristics associated with areas within a continental interior. That's to say, areas far from large bodies of water. Areas with high continentality experience large annual temperature ranges and characterized by hot summer and cold winters. Continentality is considered as a factor making desertification more likely in certain areas. Saudi Arabia is particularly vulnerable to desertification, as about 76% of its area is non-arable land. Saudi Arabia has a diversified geographic relief which has profound influence. لا ماشي لا خدتها بحار لا ماشي As I said, Saudi Arabia has a diversified geographic relief which has profound influence on its climate from region to region. While its long coastal belt has wetter maritime condition, its interior belt is under the influence of arid and semi-arid conditions. The aim of this study is to present the spatial distribution, temporal variation, and historical trends of continentality over the territory of Saudi Arabia, using NCM archive data. Moving to the first task, which is evaluation of continentality index. There are many formulas used to evaluate continentality index. The more frequently used one is Conrad Continentality Index, CCI, given by this formula, where THM is the mean temperature of the warmest months of the year, TCM is the mean temperature of the coldest months of the year, and phi is the latitude. A large annual range of air temperatures results in larger index value and consequently indicates a more continental climate. Now, according to Conrad scale, values from 20 to 50 as oceanic, from 50 to 60 as subcontinental, from 60 to 80 as continental, and above 80 as hypercontinental. The thermal term THM minus TCM in CCI formula was evaluated using NCM climate data for each station and each year over the period 1985 to 2023. Figure 1 shows us as an example a plot of a time series of these values for Qassim Met Station, but over the period exceptionally 1978 to 2023, from which we can see that the continentality is increasing over this period. My next step is to consider the spatial distribution. In order to construct a spatial distribution chart of the continentality for Saudi Arabia, the annually averaged value of THM and TCM together with their differences were calculated for all stations over 1985 to 2023 period. These differences were substituted in CCI formula using some meteo templates with the appropriate value of phi. A plot of the result values is shown in figure 2, from which many interesting features can be concluded. It may be concluded that an area of high continentality is extending from the northeast of the kingdom to the central and eastern provinces, highest in Rafah and Gaisuma, 75%. Gradual decrease of continentality towards the west is apparent all over the kingdom. On the other hand, and as it should be expected, low continentality zones are shown in the chart extending along the eastern and western coasts, but with higher values on the eastern coast, highest in Dhahran 60% and lower values along the western, lowest in Jazan 24.5. My next task is to find the historical trends of the continentality. The trend of continentality has also been estimated for all stations using a stepwise methods having two sub-periods, 1985 to 2004 and from 2005 to 2023, with their differences. Results are plotted to produce a spatial distribution chart of the trend, figure 3, from which many interesting features can also be concluded. Over the study period, this figure shows areas that experienced a substantial increase in continentality are extending over the complete northern provinces, with Rafah having 8.2% and Grayat having 9.1%, and over the northern sections of the Red Sea coasts, highest around Yumbo 2.4, which is, I think, strange for such a city. The central area, this is important, the central area that extends from Dhahran east to Al-Wajh west showed moderate either decrease or increase, minus 0.6% in Al-Ahsa, 0 in Hail, and 0.1% in Al-Ula. The central part of the Red Sea coast and Asir Mountains showed also decreasing trends of continentality, minus 2.2 in Jeddah, King Abdulaziz International Airport, and 1.7%, minus 1.7% in Al-Baha. The empty quarter is another region showing an appreciable increase of continentality over that period, 5.5% in Sharura and 4.2% in Wadi al-Dawasir. In the next step here, I tried to find the climate change effects on this continentality. Continentality is one of the main characteristics of the local climatic conditions in some regions, which varies with global and regional climate change. Changes in continentality in certain locations can be attributed to the global atmospheric warming through influencing the temperature range THM minus TCM. Increasing value of THM relative to TCM or a possible decrease of TCM with continuation of THM to increase are two distinctive mechanisms leading to such changes. Examining this effect, time series of the annual mean temperature of the hottest and coolest months were produced for all stations with their trend line slopes over the period 1985 to 2023. Figure 4 shows as an example a plot of a time series of these temperature values for Qasim Meteorological Station. I have different slides here. How can I go back? بالأحمر? Yeah, that's it. Thank you. So this is the two graphs for mean temperature of the hottest months of the year in Qasim, and the other one, mean temperature of the coolest months of the year in Qasim also. We have to notice the difference that both of them is increasing. The trend is increasing. We may notice in the two graphs that the slopes of the trend lines are both positive, increasing, but with a slightly weaker value for TCM than that of THM, 0.0772 and 0.0787 respectively. Using the slope values as indicator of the changes of continentality, Table 1 shows the results, but only for a few selected sites. It is apparent in the table that all slopes are positive. It means that warming. That's the warming with generally stronger THM slopes, except in Al-Ahsa and Al-Baha, where TCM slope are slightly higher than that of THM. But in general, they are all positive. We can consider that, of course, I did this not only for these 5 stations, for all stations in Saudi Arabia. We can consider that these results as being a consequence of local climate changes in the region. Lastly, I would like to stress that what I've done already is only the beginning of continuous work in this direction. So, in conclusion, I need to say that further research in this domain is needed, including the exploration of any future changes of continentality in the kingdom. Furthermore, the role of atmospheric circulation, such as the existing phase of North Atlantic Oscillation, East Atlantic, the Mediterranean Sea, Sudan Trough, and the Indian Ocean regimes and others must also be investigated. Such results could be of benefit for energy, agriculture, and other sectors in Saudi Arabia. Thank you very much for listening.
Thank you. Any questions? No, I want to mention that Arabian Peninsula experienced very fast climate trend, faster than the world, almost as fast as high latitudes and pole regions, and investigating all aspects of this change is very important. Thank you very much. And the last but not the least, Dr. Takashi. Sorry that for the confusion, and he will bring his presentation about the effect of vegetation of sandstones. Please.
Thank you very much, and sorry for confusing. I'd like to present about the importance of vegetation in reducing dust storms. Okay. Today, my presentation consists of 5 parts. First one is the sand and dust storm simulation by Earth system model. In this case, I'd like to introduce our MRESM2 attending at SHMIP6 and so on. And next, I'd like to show you the dust emission dominant parameters. Of course, the wind is most dominant parameters, but other parameters are also affected to emission of dust and sand and dust storm. And also, the next, I'd like to show you the importance of vegetation. And finally, I'd like to introduce some international activities. Of course, SDS WAS and also other regional joint research project and so on. And then I'd like to summarize my presentation. And first, I'd like to show you the why we need a system model in estimating sand and dust storm. Upper figure shows the UNCCD dust source map. Maybe you see this map in many places. And the dark area is the dust source area, and the Saharan Desert, and also Middle East, and Central Asia, and also the East Asia, Australia, is the dust source. And the bottom figure shows the LAI observed by satellite. In this case, MODIS observation. And there is a low LAI area in the Saharan Desert and Middle East, East Asia, and Australia, and so on. So you can easily know that the LAI is the very important factor when we consider the quantitative amount of dust emissions. And now I'd like to show you our Earth system model. I am from Meteorological Research Institute and Japan Meteorological Agency, and now we are developing our Earth system model. And this is the older version, MRESM2. This model attended SHMIP6 International Intercomparison Project. And in this model, we treat many components, not only atmosphere, ocean, but also aerosol. Aerosol means the right top box. We call it Mazinga Mark II. This is our aerosol model. And in this Mazinga, we can treat 5 major aerosol species, of course, including dust, and also sea salt, and sulfate, black carbon, and other organics, and so on. And in this system, we treat each aerosol species assuming external mixing. So it is simplified, but the merit of this external mixing is we can separate each aerosol effect. And also, our model combined atmospheric chemistry, MRICCM2, and also ocean, sea ice, and land surface model. In this land surface model, we can treat the vegetation. And when the rain falls and the leaf growing, and also the carbon affects carbon cycles. So now we are developing a new version, MRI ESM3, for to attend the CMIP7 next intercomparison project. And this is the schematic view of our land's dust emission scheme. When the strong wind blows to the arid or semi-arid area, the dust is emitted. And the dust emissions are proportional to the third to fourth power of wind speed. So it is the dominant parameter, of course. But the dust emission is affected by land surface conditions, soil moisture, leaf area index, and also the snow in the land surface. So quantitatively estimating dust emissions precisely is an area of great challenge for us, because a few years ago, dust model intercomparison was executed by Professor Uno, Kyushu University, but the paper says that there are very large difference among models. So there is maybe a great challenge for us in dust emissions scheme. And I'd like to show you the global warming experiment using our Earth system model, MRI-ASM2. And we executed 5 main SSP scenarios, SSP 119, 126, 245, 370, and 585. And the bottom figure is the key result of my paper. This paper shows the dust emission amount at Gobi Desert in East Asian desert. And the result is that the early spring and late winter, the dust emission is extremely increased for global warming accelerated scenarios. And this, from now, I'd like to show you some parameters affecting the dust emission amount. The first one is the surface wind velocity, friction velocity. And of course, this is the most dominant parameter in dust emission. And these two figures shows the global warming scenario and warming suppressed scenario, the correlation coefficient between the dust emission amount and friction velocity. And there is a high correlation area in Sahara, Middle East, and Central Asia, East Asia, and Australia. Of course, the sand and dust storm is emitted when the strong wind blowing near surface. So it is very constructive result. And then I'd like to show you the erodibility, dust emission amount and erodibility. Erodibility means the success rate of land surface to wind erosion. So in this comparison, the Australia is the highest correlation, but the Sahara is not so have correlation. So and also the result is that the global warming scenario and suppressed scenario, there is no significant difference. And also, I'd like to show you the dust emission amount and snow depth correlation. Of course, there are almost little small snow in Saharan desert, so we cannot see the correlation. But in East Asia, you can see that there is a negative correlation area. This means that the snow cover is one of the dominant factor in considering the dust emission amount in East Asia. For example, Gobi Desert or Taklamakan Desert. This is the one key result of my paper. And from now, I'd like to show the vegetation dust emission amount and vegetation correlation coefficient. And so, seeing this figure, there is a large negative correlation area in Australia, and also some negative correlation in Central Asia and East Asia. So this means also the Saharan desert, there is almost no correlation. among dust emission and vegetation. And this slide shows the area trend from observed by MODIS satellite observation data. In East Asia and India, the recent 20 years, the area increases. This is not the dust source area, but maybe affects some dust emission or other kind of parameters. And also, I'd like to show you the East Asian dead leaf effect. This is the paper from Wu-san, my colleagues, and she found that in East Asia, for example, Gobi Desert, dead leaf is the one of the dominant factor which affect dust emission. So the dead leaf, it is difficult to retrieve from MODIS area, but soil tillage index, using these parameters, we can detect the dead leaf effect, and also that she found that this dead leaf affects dust occurrence more significantly in April case. And so I'd like to show you some international activities. And of course, this figure shows some presenters in today, and we have 4 SDS-WAS regional nodes, NAMI node, ASEAN node, and Pan American node, and GCC node. And in each node, the countries collaborated to share their observation data and modeling data and so on. And I hope in the future we can exchange our data among the node in the future. And this bottom figure shows the ASEAN node activities. And in ASEAN node, they're hosted by CMA. They collect the 7 dust forecast data, including our JMA, and also CMA, KMA, and FMI, and ECMWF, and NSEP. So, and also they calculate ensemble mean product. In the future, we hope to using this data to considering the importance of surface parameters. And also, I'd like to show you the regional collaboration. This is the named TEM project. TEM means the Triplet Environmental Ministers Meeting, TEM. The 3 countries from China, Japan, and Korea. And also the Mongolia is an observer. And we started our joint research since 2009, and we have 2 working groups. I and Jukjin Won-san attended working group 1. And this group focuses on DSS monitoring and modeling. And also the important feature is that we have working group 2. And this group focus on research on countermeasures at the source area of DSS. This bottom picture shows their field study in the Chinese site. And now we are enhancing the collaboration between our working group 1 and working group 2 to countermeasures for combating sand and dust storm. And of course, the surface condition is very important. So in the future, such activity is very important, I believe. So this is a summary of my presentation. We need an Earth system modeling approach when we considering the sand and dust storm. Near surface wind is most dominant, but we have to consider the importance of vegetation and snow depth and other parameters. And vegetation affects dust emission by LAI, and also we have to consider dead leaf effects. And to overcome these issues, we have many international collaborations, SDS-WAS, and also regional TEM activities to countermeasures for combating sand and dust storm. Thank you very much for attention.
Thank you very much. Questions, please.
Thank you very much for a very good presentation. My question is related to, you mentioned that dust emission is correlated with the third or fourth power of wind speed. And as you also know, now if we consider only this is a single factor, but as you know, dust emission is a complex interaction of multiple factors. Have you considered, for example, the complex interaction of other drivers such as precipitation, NDVI, and valley depth, all in one equation?
Yes. In my Earth system model, and we calculate the, as you mentioned, parameters, wind speed and LAI, and snow depth, and soil temperature, and so on. Of course, this is very, very complex processes. And now we try to estimate the dominant parameters in this area. The result is that wind speed is most dominant. But in the season end area, snow depth and also LAI is shows the important factor. Thank you very much.
Thank you.
Takashi, I have a question.
Yeah.
So what is the resolution of the Earth system model you used for this study?
Yes, thank you. Very good question. The horizontal resolution is aerosol is about 180 kilometers, very coarse grid. In weather dust forecasting, we use 40 kilometer grid. And so, very important suggestion, and we try to use more higher resolution model in the future.
Do you use source function when you model dust generation?
Pardon?
Do you use source function?
Yes, source function. Yes, based on Shao scheme. Yes.
Thank you.
Thank you.
Thanks very much. Takashi, you can give it to me. Thank you. Takashi, 1 second. There is a question.
Many thanks indeed for excellent presentations. Regarding to, I think, can we go back to slides? If not, so regarding to erodibility, so I didn't see big differences or any tiny differences between two scenarios.
Yes.
Yeah, it looks the same.
Yes.
The other question, I think you said scenario SSB 5, 8.5, get most warming.
Yes, most warming, yes.
Yeah, and scenarios SSB 1.9, I think in Australia, get positive correlations and weak correlations in Sahara.
Yeah.
I think it's going to be weak correlations in both of them. Yeah. If you can go, just do some analysis, and can you find, I think it's going to be the same.
Yes. In this calculation, I use the 85 years monthly mean result. And so, I was surprised that there is no significant difference between the SSP 119 and 585. So maybe this means that our model can represent such almost same processes dominating almost same processes. I'd like to research further, find that there is no such difference in the future. Thank you.
Thank you, Takashi. We have time for general discussion on this session. So, and if there is interest to give your thoughts, please let me know. I would say it's what is very important. Is coming from this session that so it is complex coupled system all processes are connected. And in some aspects we better developed, in some aspects we less developed. But it is important to account for this interaction. Please.
Thank you. I have two thoughts from the discussions and everything we heard this morning. The first one is perhaps we need to start thinking about source regions and receptor regions. The multiple things are different. The scale of the challenge is different. The Godzilla event in Barbados was 300 micrograms of PM10. Here in the Middle East, we get events at thousands of micrograms per at source region. So the interaction at source versus the transportation and processing at receptor might have different impacts, different properties, and we need that discussion to be captured scientifically. The second thought is I think there's a lot of interaction that covers multiple areas between health, meteorology, atmospheric chemistry, and more integration of this is really important so we can address this correctly together as a community, as joint community. And finally, the regional aspect of this in terms of collaboration at the regional level is immensely important. So these are the three thoughts I have.
Thank you. Daniel, do you want to add something?
Yeah, I absolutely agree. This is, I think, is part of the reason that Juman and the colleagues in the Gulf Cooperation Council region that we set up this meeting. It's very much my hope. It's my first time visiting this country, but I'm really happy to see all the work going on and then to meet you in person. I hope this is just a beginning of long-term collaboration. I totally agree with all the points you are making. And we have the framework, now we have the $10 million at hand, right? So that should be a lot of things we can do together. Yeah, feel free to get into touch. And I look forward to working with you all. Yeah.
Okay. On this positive note, I close the session.
Okay, because we are running very late in the program that we were planning, we will skip the break because the lunch break was very close. And we will ask to the next moderator, Dr. Ali Al-Hamoud, Dr. Ali, to take the floor and moderate the next session.
Starting from where?
All of them. Oh, okay, just a logistic issue. From WMO perspective, I support all the points that was raised in the panel. We have this issue with Saharan dust, with Arabian dust, with the big deserts that you have very strong events in sources, but it's spread around the world. Then it's totally right. It's not the same problems, and we have to face it. Now we can start the next session.
Thank you very much. Now we start with Dr. Abdul Majid Haddad, the Deputy Regional Director of the UNEP Regional Office of West Asia, for his presentation, Political Framework and Regional Coordination Integrated Approaches to Address Sand and Dust Storms.
Good afternoon. My name is Abdul Majid Haddad. I'm Deputy Regional Director for UNEP, United Nations Environment Program, West Asia Office. As you know, UNEP has been there for like 52 years. We are based in Nairobi, and we are the coordinating body on environment within the UN system. Our association with the sand dust storm goes long back, and we have collaborated with our sister agencies and governments in conducting a number of assessments with regard to sand and dust storm. The last one was the global assessment on sand and dust storm. That was a basis for actually a decision by the UN General Assembly encouraging countries to collaborate to combat sand and dust storm. Also, we collaborated with UNCCD Secretariat, with WMO, and with other agencies to have the toolbox on sand and dust storm, and also the resource map that was presented some time ago. My presentation will focus on the action side, on the policy side. So we always see a gap between science and policy. Lots of science, lots of research and so on, but we are still not there in terms of policy and in terms of action to actually reduce or to combat sand and dust storm from its root causes. So I have two words in the title of my presentation. One is the framework, the cooperation framework, and the other one is the integrated approach. They are all goes together. Why do we need cooperation framework? As I said, we need to link science with policy. Okay, we need to address the problem collectively because dust storm has no border. It's very transboundary in nature. And of course, my colleagues in the previous sessions, a lot of research and a lot of data that I did not want to really repeat. But as we know, it's a transboundary issue. So no one country can actually address it alone. The second is that we see that there are fragmented actions, and focus on certain issues rather than the others. So we need to bring all these actions together through a collaboration or coordination framework. And already we have the political will, and also we have the political mandate and the political backing of bringing this cooperation together, as articulated in many decisions of the governing bodies of UN organizations, such as UNEA, which is the governing body of United Nations Environment Program, the WMO, and UNCCD, the COP16. I think there is an agenda item that has been there for some time for COP to decide on, and also FAO. So each agency has, and on top of that, we have the General Assembly resolution. So we have the political backing, we have the political mandate to act. Then it is linked also to other global issues, such as air quality, climate change, and desertification. And this is a plus. We can capitalize on this and to integrate into these global processes within the climate, desertification, and air quality. We have also good capacities existing, whether it's in the region or global. So we have to capitalize on these kind of things. And we can build on the successful examples, not only from our region, Asia region or Asia continent, on sand and dust storm. I think Professor Takashi mentioned the 3 countries collaborated on sand and dust storm: Japan, China, and Korea. Okay, this is a successful model for collaboration. But also there are collaboration on air quality, improving air quality across the globe, using the same sort of concept, regional framework, some sort of agreement, political agreement, funding, and so on and so forth. then we need integrated approach. So if you address the root causes and solve the problem from the root, you are forced to actually act on multi-dimensional problem. Like you have to tackle land management, water management, you have to tackle urban expansion, industrial, mining, for example. Mining contributes also to sand and dust storm. We should also have integrated approaches, science-based and evidence-based. So whatever action we do, we have to have evidence of impact. So it's very important. And we need also governance framework that actually support or strengthen the integrated approach that is needed. Impacts, we know that. I mean, you have seen many photos. These are just to add to your memory from the impacts of sand dust storm from our region. And it's transboundary. So you have export, import. I call it dust budget sheet, okay? So some countries, they have local sources. They have also sources to export. I mean, transboundary, beyond their borders. And also, countries receive. And this is across the region. There is no country that only have source of dust, but also receives. I mean, if you take Iraq, if you take Saudi Arabia, even if you take countries like Kuwait, like Jordan, like Syria, still there are local sources, and there are also sources coming from outside the border, and there are actually shared sources, like what we see in the border between Iraq, Syria, and Jordan, the Hamad Basin. That is a source of, and also between Iran and Iraq. In some areas, there is also a common source. So we need really to, when we would like to tackle the issue, we have to tackle it from its multidimensional. This is a simplified framework on how to actually act on the sand and dust storm. So it has the climate dimension, it has the impact dimension, and it has the mitigation and control dimension. And above all, you need to have very good observation network, monitoring, you have to have early warning, and also you have to have very good research, networking, and capacity building in order to tackle this issue. So you have to address the full cycle, causes and sources, the transporting dynamics, monitoring, early warning and preparedness, impact assessment, prevention and effective mitigation measures, and also the management. It's a textual presentation of the previous conceptual framework. We had one example, which is Iraq. In 2014, they developed a national program to combat sand and dust storm, and we applied this conceptual model of integrated approach, bringing the climate trend analysis, starting with it, and then we had land use trend analysis. We did the diagnosis of causes and identifying hotspots and sources, then identified mitigation strategies and projects, then assessed the capacities for observation, monitoring, and early warning, and then we actually had established institutional financial arrangement to actually take the program onward, okay, and of course monitoring and evaluation of the program itself. So this was developed in 2014, and I think the model that we applied, it was a joint effort by UNEP and FAO. It was actually a model that can be replicated for other countries. It was fully consultative, participatory process. We brought all the stakeholders from different sectors to actually help in the formulation of the national program. Then back in 2013, the regional office of UNEP initiated a regional program called the Regional Program to Combat Sand and Dust Storm, and we proposed a stepwise approach to combat sand and dust storm from science to policy to action. And this was the proposed structure of this program, and this is only a model structure. It was not really endorsed, but it was proposed to countries. And I think we have an opportunity here, since I think we are advanced, more advanced than 2013, we have an opportunity here really to go back to this kind of framework and study it well. In order to be successful, you have to have the regional framework, I mean an agreement of some sort between the countries to collaborate. You have to have the financial facility to support the actions, and you have to have a technical program in order to guide the countries on action. And these are some of the supportive enabling structures like a regional center. And very important to mention that at that time, the proposal for regional center was well received, but it was not implemented. And I think Saudi Arabia, thankfully, took the initiative and established this regional center now. You need to have all these components of the technical program, and the most important part is actually actions on the ground. Each country has to have a country action plan or action program to actually address the root causes of sand and dust storm. Here I'm trying to actually emphasize the point that it's still viable to have a regional program and to have a regional approach, because we have complementarities between countries. We have capacities, but it's in different countries. So the regional framework or the regional program will help actually gather these kind of capacities in order to address the problem. These are some of the examples. For example, if we look at the dust monitoring, Kuwait and Saudi Arabia, they have very strong dust monitoring network or system, okay? If you go to, for example, dust mineralogy and geological studies, we find that Turkey, Iraq, Kuwait, they have these kind of studies. So if we have this regional framework, we can build on these capacities to actually support the implementation. My concluding remarks, as I said, sand and dust storm is transboundary. No country can tackle the problem alone, even if they invest billions of dollars, okay? So collaboration is needed. Sand and dust storm is multi-dimensional. It crosses a lot of sectors, land, water, climate, what have you, and it requires an integrated approach based on science. We should target the root causes. So we identified, for example, in the regional program, we identified hotspots in each country. We should target these hotspots. And actually, part of that implementation, I think we have a couple of projects that targets the hotspots of sand dust storm sources. One of them is funded by the Global Environment Facility, but also another one funded by Kuwait, I think, between Kuwait and Iraq, to target certain hotspots in Iraq. Actual regional cooperation started with the establishment of the regional center in Jeddah, and the UNEP and the regional center are embarking on developing a master plan, a regional master plan to combat sand and dust storm, and we hope that the master plan, once developed, will serve as a roadmap and guide the action of the countries on the ground. Last but not least, sand and dust storm is cyclic, it's long-term. The sustainability of efforts and resources are needed to achieve success. Thank you very much.
Thank you, Dr. Abdul Majid. Dr. Dr. Abdelmajid Haddad, thank you very much. The Deputy Regional Director of the UNIP Regional Office for West Asia. Very interesting presentation, which is really related to the political framework in terms of tackling sand and dust storms. And by the way, there is, as you know, there is the source prevention as well as the impact prevention. Now, in terms of the impact from other countries or the impact from other sources, the first study which has been done by Nick Middleton from Oxford University, he has published one paper. If you are interested to read that paper, it is Middleton and Ochang from Korea. They have published one paper related to impact mitigation in 2017. And after that, actually, I have published one paper also with him this year, with Dr. Middleton, on new recent developments for impact mitigation. So as you mentioned, this integrated approach is very helpful for the multi-countries. Is there any question for Dr. Abdelmajid? Yeah? One question.
Assalamu alaikum. Abdel Nasser Rashash, remote sensing expert. Really, many thanks for your presentation and this integration approach, because you identify to trend analysis when we identify or trend on climate elements or vector, and the trend of land use, also trend in vegetation, I think located in land use. So I try or test this approach. It's have very accuracy result for identify desertification and degradation land. So I think I not tested to sand and dust storm, but I think it will appear a very good result. Many thanks.
Thank you very much. What I did not mention is that we had the climate trend analysis from the meteorological data that we have, and we went back like 50 years ago, because the first record were 50 years, and we had only 1 or 2 stations in Iraq at that time. And also for the land use, we used the satellite image, satellites, and we saw the land use and land cover. But also, teams from the project went to actually the sites for verification, okay? And we have to be careful when we mention sand and dust storm, because two are different. You know, if we are talking about sand, is different from dust. The mitigation of sand is different from mitigation of dust. The dust are very fine particles, okay? They transport very quickly, and they take very high, they spread at height. So the mitigation is very specific to that. The sand is mainly localized because of coarse particles. But to cut the story short, we complemented our sort of disk study with ground truthing. So we went into the field and identified these areas. We analyzed the sand, the soil, to identify the the size of the sand, and also to see the extent of the problem, especially the land and water issues in Iraq.
Thank you, Dr. Abdelmajid, for the good presentation. Thank you very much. We'll go for the next presentation, Dr. Sarah Basart, which is related to international cooperation.
Thanks everyone to stay in the room. I will be a kind of overview of things that was already mentioned during today in the different talks. I'm Sarah Bazard. I'm scientific officer at the World Meteorological Organization in one of those research programs at the organization that is focusing in atmospheric composition, meaning atmospheric chemistry. Oops. It's been mentioned several times. Experts here in the room have mentioned that in sources we have very extreme events, and these events are hitting us, and it's really sometimes a reduction of visibility, a reduction of the levels of air, or of the air that we breathe, but in some cases can hit infrastructures, meaning buildings, roads, traffic. Everything is connected with these extreme events. But if we are going far away to the reception points, also in Europe, we have receiving large amounts of dust, and this dust is transported. It's not emitted in the sources. And this is all the examples that you can find, for example, in Europe, associated to events more connected with Saharan dust. South of Spain, middle of the Mediterranean, Crete, Paris, also these reddish colors in the Alps, and it was mentioned several times, all the impacts that this dust deposit on the surfaces, in the snow, also in the air that we breathe, are hitting us. Then for the reason, it is a UN concern because it's worldwide, it's covering not just sources, it's areas beyond the sources, and as it was mentioned several times, we have to face the impacts in a different way depending on the context, regional context, but also the sector that we want to target. And it's because of that that the General Assembly, the United Nations General Assembly, proclaimed 12th July as the International Day for Combating Sun and Dust Storms. And this day is basically to raise the awareness about the importance of this environmental hazard in health, but also in sustainability. Also, United Nations promote a coalition of different agencies, the United Nations Coalition for Combating Sun and Dust Storms, that I will show you now. And also we have the UN Declaration for the New Decade to combat increasing sun and dust storms from Africa to China. And this was happening in the last 5 years. That means that there is a large interest from the community to support mitigation and adaptation strategies. And touching the coalition for combating sun and dust storms, as we mentioned several times, sun and dust storms impacts covers 11 over the 17 Sustainable Development Goals. This is important because it's hitting different aspects of our life. And the coalition is now involving more than 15 UN and non-UN agencies. And the chairs of the coalition at present is ESCAP and ESCIWA. And also I want to mention the contribution of the World Meteorological Organization because we are leading the activities of forecasting and early warnings. And this is the kind of things that we are promoting as a coalition. WMO is very active collaborating with many different agencies in the UN family, as WHO, UNEP, FAO, UNCCD, ESCIWA, ESCAP, and we are trying to promote the use of the available information from a perspective of a technical agency, where we have here atmospheric experts that can support these assessments, for example, and also to address the risk posed by sun and dust, and to promote action plans and to support action plans in the different regions. In the bottom of the slide, you can see some examples of this UN initiative, like Global Assessment of Sun and Dust Storms led by UNEP, the Sun and Dust Storm Compendium, UNCCD, the impacts of sun and dust storms on oceans, UNEP, but also the Sun and Dust Storm Risk Assessment in the Asia and the Pacific promoted by ESCAPA team. And also associated with the NCCD, you saw this map several times today, is this SDS source-based map, that here we have the lead author, the principal investigation, which is Anna Vukovic, and we are trying to go further to where are the 4 sources and potential sources that can emerge in the future years connected with land conditions. And this is the type of high-resolution data sets that we want to give to the different potential users to advance in these strategies, for example. Also, FERAS this morning introduced these guidelines and reports promoted by FAO connected mostly with agriculture and policy. You can take a look. I don't want to go into the details because we don't have many time today. But also, as mentioned in several presentations today, the WHO air quality guidelines are having a specific comment on sun and dust because we have currently insufficient quantitative evidence of the impacts of aerosols in our health. And there is a specific mention on sun and dust storms. And in the presentation of Dr. Sorry. It's very well explained, all the items and questions related with this lack of knowledge. It is connected with size distribution, is connected with chemical composition. Also, I want to mention that WHO and WMO, we are preparing a new report that is basically a review on sun and dust storms' impacts on health, and it's planned to be launched next year. But also, and not the least, is the UN Early Warning for All. This is a United Nations initiative that involves all United Nations agencies and is promoted by the General Assembly, by the Secretary General, because suddenly one day someone discovered that 50% of the countries of the world are not protected with early warning systems. And in the list of early warning systems, it appears in a very top 10 rank sun and dust storms. In this initiative, there are different specific pillars, like this disaster risk knowledge, meaning when dust is a problem, observations and forecasting, what we need for promoting early warning systems, dissemination and communication, when we have to alert the population, and also preparedness and response, what we can do to avoid the risk. And this is where WMO is going into the game, because the WMO is like the United Nations agency specialized on weather, climate, and water, which is the three elements that are connected with sun and dust storms. We are supported by 193 countries, meaning members. The headquarters is in Geneva, Switzerland. We are coordinating the work of more than 300,000 experts from meteorological services, academia, and private sector. And here in the room is a good example of contributors to the WMO activities. And also we are co-founder and host agency of IPCC. Why WMO is a key player in these discussions? Because we are connecting science with data and with services. We are having a framework of work in which research is promoted to the exchange of information with any potential user that needs any kind of parameter, but also we are supporting the design and development of services to avoid hazards and risk. And in this context, one of the key activities at WMO is the Sun and Dust Storm Research Program, this SDS was, and it was launched in 2007. And why? Because we did realize, all of us, that dust is not a local problem, it's not a regional problem, it's a worldwide problem, and for that reason we need to promote this international collaboration. And as you see in many different presentations, we are working in the concept of global coordination based on regional activities. And as you see, there are 4 main regions that are collaborating within WMO. And the important thing here is that you have to understand that this group of experts are working to promote international collaboration between weather and climate communities. We want to identify and assess the impacts of sun and dust storms to support the assessment of the cost, benefits, and mitigation adaptation strategies. We want to promote the use of the current available and most advanced sun and dust storms products. And also we are working a lot to build capacity and facilitate the access to all this information, including the dissemination and awareness of these problems. And today is a good example of the things that we are trying to push together. And just my final remarks, I think that you don't need that I read all the slide, but the keywords probably is serious hazard, cross-disciplinary knowledge, international collaboration, and also that WMO is here to support all your activities, and we are welcome to collaborate with any region, any country, any agency, any institution that is looking for this support. Then with that, just I want to thank all of you to be here, also to all UN agencies that are here, the experts and contributors of the SDSWOS, and especially Juman that was organizing all this nice day dedicated to sun and dust storms. And with that, that's it.
Thank you, Sarah, for a very good presentation regarding the international cooperation of sand and dust storms. As she mentioned, as we are sitting here, this is a good example of an international cooperation under the supervision of Mr. Ayman and Mr. Jam'an al-Qahtani, who invited all the different countries for cooperation. Thank you very much. Any comments, questions? Quick question? Thank you, Sarah.
Thank you.
Okay. Our next presentation, our next presenter, which is really also a good example of international cooperation, Dr. Amira Al-Hassan, UN Habitat Kuwait and GC Office, for her presentation, the role of society in supporting the state's efforts to combat sand and dust storms by greening open public spaces.
Hello, good afternoon. Let me start by, until they put my slide. Okay. Okay, my name is Amira Al-Hassan. I'm head of UN Habitat. Our office is located in Kuwait. So let me start by introducing UN Habitat. It's an agency that is part of the United Nations. It was initiated in the 1970s to tackle any issues related to cities and urbanization. And basically anywhere that humans live is UN Habitat mandatory work is linked to. So today I would like to start by thanking Saudi Arabia for hosting COP16, which is a very golden opportunity to exchange ideas and expertise amongst ourselves and learn. It's a learning process, and I'm grateful for that. The second thing, I would like to thank Saudi Arabia for the Green Middle East Initiative, which is something very brave because it's a big and huge challenge that they decided to take over their shoulders, and I congratulate them for this. Okay, I would like to also say that you have covered many issues since the morning, so I don't know what additions I will make to your contribution, but basically my presentation will be about the community role in mitigating the effect of environment on the climate change on their cities. So leveraging community action for environmental resilience. We have 4 things to think about that is related to this issue. First is our sustainable urban future is linked pretty much to people's actions in their cities. And the second thing is the GCC location in the map by default generates the sand and dust storm because this region enjoys a very high arid climate, very high temperature in the summertime. It's a desert climate. That means very cold in wintertime, very hot in summertime. So this is really a complex factor that is add to this the effect of climate change on this region with the seasonal shift and many complexities on the region. Third thing is the engagement of the community in actions, because nothing is only related to governments or organizations, or it should be a collective work. And in light of urbanization, increase of building cities, new cities infrastructure, this makes things more complex. Finally, what is the UN Habitat role as a regional intervention and support to these efforts? So the importance of combating sand and dust storms. First of all, as I mentioned, the geographical location of all the 6 Gulf countries by default result in a very arid climate, low precipitation rate, sand dust storm used to be 60 years ago 20 events per year, and now 210 days per year. So it's the increase of the events means that there is a socio-economic, environmental impact on the residents of the cities and the residents of this region of the world, resulting in very huge economic loss. And at every level, this region is being impacted by the sand and dust storm. We witness that urbanization is increasing in this part of the world, but in light of the effect of climate change, yet the governments are doing their best to add interventions that make, for example, energy efficient interventions, encourage, as we saw here in Saudi Arabia and UAE, encourage public transportation, encourage tertiary interventions and solid waste management, also all these interventions by the governments. And yet we have also to do more at open public space level, because with all these interventions, still the impact of climate change is increasing. In light of this, the United Nations Coalition on Sand and Dust Storm has done so much work, but in my position, in my capacity, I will now shed light on the Kuwait Plants Campaign, which UN Habitat Kuwait has initiated in 2019. This campaign actually aims at addressing sand and dust storm and greening open public spaces at a local level and engaging all sectors of the society. So when we initiated this campaign, which you can search, by the way, in the search engine in the internet, if you write in Arabic Al-Kuwait Tazra, Hamlat Al-Kuwait Tazra, you will find plenty of information and pictures and videos in the YouTube and other search engines, which I don't want to put here and take time on this issue. And also in English, you can write Kuwait Plants Campaign. It is a national campaign. Our main partner and stakeholder in this campaign is Ministry of Foreign Affairs, as they are our stakeholders and our partners since we opened the office in Kuwait. And then add to this other stakeholders, for example, the Public Authority for Agriculture and Fisheries, the Public Authority for Environment, we have the Ministry of Education, private sector, private schools, also NGOs, volunteers, and so on and so forth. So the objective, what is it actually? We need to leverage the understanding of what is sand and dust storm, because once people are educated about what's happening, then they will take better measures. I will give example away from the sand and dust storm is when Corona hit the world. Transparency was very important issue in teaching people that the Corona is basically linked to hygiene and cleanliness, and people needed to learn more about that part of health related that impact their health and their existence. In the same way, we had to raise awareness of people on the impact of sand and dust storm. By this, I mean morbidity and mortality rate. People, when you address them psychologically, they respond better. So in the campaign, we had to raise awareness on what is sand and dust storm impact on our lives, how the aviation stops, how our daily life stops, schools closes, people with any respiratory problem might severely be affected. So raising the awareness on their impact, then comes the second step, which is, what can I do? Is it the government work or is it our work? In this case, okay, the government is doing their job. Other institutions and entities in the government and private sector are doing, but as a citizen, as a resident, as somebody who lives in Kuwait, what can I do? So in that sense, we face so much criticism, actually, from people receiving our awareness campaign. Why is that? Because people think, what are they talking about? This is a hot country. The plants will not survive. If I plant a tree or a sapling or even a seed, then we are now jeopardizing, because our effort might be useless. Second thing, there is no water. We don't have precipitation in Kuwait. We don't have rivers in Kuwait. We 100% rely on desalination of seawater. So why do I want to plant a tree? So we have to raise their awareness on the impact of planting trees on their health. Also, we had to give real examples on what planting trees and plants affect on their lives. So we brought two examples and two living evidence of the effect of planting on their lives. The first one I will tell you now. There is a big park in Kuwait, used to be called Al-Hizam Al-Akhdar, or the Green Belt. Now it's called Hadiqat Al-Shahid, or the Shahid Park in Kuwait. There is a scientific evidence that Shahid Park is in the middle of urbanized area, and yet the temperature in this park is lower by 3 to 4 degrees in comparison with the buildings around it. So we had to take pictures of this scientific study and show people what has happened after trees were planted in these. And then, okay, after promoting environmental awareness, we have also to show people that the mortality rate is affected pretty much by the events of sand and dust storm. For example, there is a day where the sand and dust storm was very heavy, that there was 7 cases of death related to respiratory system problem and sand and dust storm. So in this campaign, starting from 2019 up until today, 6 years, we managed to spread and hand over and give people thousands of tree and plant saplings. We engaged many sectors of the society, schools, public schools, private schools, even heads of missions. I mean by that, all the embassies in Kuwait engaged with us, ambassadors, heads of organizations, private sector. Also, we did composting. One of the very important composting campaigns we did is with a coffee company that has been, sorry, they had so much coffee that has been left and expired. We use it in our campaign. So we raise awareness on using raw material to do composting around us, okay? So the collaboration is ongoing, and the outcome is increased public engagement that we witness throughout the publication of people's work in the multimedia. Any social activity is uploaded in the internet, and you can see how much people are being affected and impacted by our campaign. I will give you one example now from Shamia Reserve experience. We linked up with a community that is basically located in a sports center. This sports center, if you go to Google Map and write مركز شباب الشامية أو أكاديمية الشامية or Shamia Youth Center, it is actually a sports center in Kuwait, a huge It is equipped with facilities, but at the back of this sports center, there was a huge land that is empty with no vegetation whatsoever. It was loose sand, as Kuwait is suffering from desertification since the end of 1970s until now. So the back of Shamia Youth Center has a new intervention from society that is composed from housewives, NGOs, youngsters, anyone graduate from university and waiting to be employed. They have their leisure time coming to this youth center on Saturday morning only between 10 a.m. until 1 or 2 p.m. That's it. Every Saturday, unless there is something that's engaging them. In this center, we carried out many awareness campaigns. We taught people, for example, how to use the plastic bottles to plant simple trees just from seeds, how to maintain the life of the plant while I'm traveling abroad, what can be done. And the community had raised so many issues, many questions. So we took the opportunity also to answer questions addressed by people who took from us, the saplings. So we give them, for example, moringa tree. And then we say, okay, do you know what's moringa tree? Do you know how it survives? This moringa can be used as salad. It can be also used as a tea. It grows very fast. It's a very fast growing that reaches 2 meters in 1 year. So it's very important for people also to see that their plant grow very fast, or maybe other plants that survive in Kuwait and native plants of Kuwait. And then we answer their questions. For example, how do I irrigate? How do I maintain this plant? Okay, when summer comes, what can I do? If I'm traveling to Europe, in the summertime it's very hot. It reaches 55 degrees centigrade. So what can I do? We answer their question. For children, we taught them how to compost the leftover of their food, how to use plastic, recycle, and so on and so forth. So we achieved so many planting activities. We engaged also Kuwaitis and non-Kuwaitis, all are the same, and also people with special needs, children from the age of 5 and up until any age you would like to mention. So all in all, what I'm saying is that everybody was welcome on board this campaign. In fact, because people who go to Shamia report on the media, we started receiving people from outside Shamia, as far as Ahmedi, which is 1 hour drive or 45 minutes from Ahmedi. So we are now seeing people from outside Shamia thinking, okay, can I replicate this in my school? Can I replicate it in my neighborhood? Can I do the same thing in the garden of my house? We are building a new house in Al Mutla area, which is a new, or in Jabal Ahmed, which is a new area. How can I do that? So we engaged other non-local communities in public activities. And as I mentioned earlier, the temperature as an evidence of the successful intervention. In the Shamia area, we have invited people. At the time the temperature was 50 degrees. And we brought the thermometer and we show them that outside it's 50 degrees centigrade. Inside Shamia, it is lower than 30 degrees centigrade. It's between 25 to 30 because of planting without using air conditioning means. It's only planting trees in that area. So people witnessed with their eyes the difference in temperature between outside 50 degrees and inside 25 degrees, which convinced them really to plant, and how effective a planting is. So the inclusive participation actually leads to long-term success and demonstrates scalability for other urban areas in the region. I want to conclude here that it's a critical thing to engage local communities on what we are doing, because working alone in silos will lead to results, but a collective effort will do much better results. So sharing success stories will help others to imitate and replicate your experience. So we, in order to do that, also we have to give the local communities their ownership and actively participate in creating sustainable urban environments. Second thing, we need legislations and laws that allow local people to do their interventions, because if I want to allow them to take part in the sports center in Shamia, which is allocated for sports center, then I need law or a window gap for them to enter. Otherwise, if the laws is not flexible, then people will not take those measures. Finally, I would like to say that together we can transform environmental challenges into opportunities for a greener and more resilient future. Collective efforts lead to better engagement of all sectors for best results. So all in all sectors of the society, public, private sector, the NGOs, volunteers, even people visiting the country on a short term, also they have their own experience, they have their own knowledge to share with us, which we find very important and we appreciate. Thank you so much for listening, and I'm ready for any question.
Thank you, Dr. Amira, for the very good presentation regarding the involvement of the society and the NGOs. Very successful effort which has been done in Kuwait. Any questions, remarks?
It's not the question. So I would like to thank for this enthusiastic approach to the problem. So we know that vegetation cool the environment. So that we know for hundreds of years, right? Maybe thousands. But it cleans because it evaporates water. How much it evaporates, that much it cleans. It cools. So the question of water still is very, very important. So we actually, vegetation evaporates as crazy. That's why this area is cooler, but it is also nicer and could be used for for sport or for other needs. So very important, but water is still the problem to produce this.
Yes, I agree with you totally. There are challenges also we have to address in our interventions. But now you remind me of something, by the way. 60 years ago, prior to desertification in the Gulf areas, old women in their 80s remember that during the springtime, when they have young children, they should pay attention to them. Because of the high vegetation, they lose their child. In the middle of the desert, can you imagine how the vegetation is? And they used to be careful not to lose the child, otherwise they will not allocate the child. So we wish that this comes back again, and with a collective effort, I'm sure we will do that. Thank you so much.
Thank you, Dr. Amira. Very good talk, very interesting. Now, Sarah, we have, this is the last session, unless there is one online. Right? Okay. I believe there is one online session from Dr. Nicolas. Successful international experience in dust storm management. correct? Yeah. And this is supposed to be an online. Dr. Nilofar, you can start if you like.
Can you hear me?
Yes, we can hear you very well.
Okay, good afternoon, everyone, and thank you for the time that you allocated to this presentation. First, let me to share my screen. Okay, can you see my screen?
No, not yet. Yes, now we can see your screen.
Okay. So good afternoon, everyone. I would like to share with you how we reach the regional plan of action, which is the agreement and the steps that we took today. I will highlight just a few key points to say that this process included intergovernmental agreements, which anchored in resolution from the General Assembly and the ESCAP Commission, and it was also evidence-based and involved consultation leading to the formulation of the regional plan of action. Now, of course, we are working on the actual implementation of this regional plan of action. During my presentation, I will focus briefly on evidence-based we produce and the consultation and the implementation phases. And in terms of evidence-based, we work towards the development of risk assessment in Asia and the Pacific. And it was really groundbreaking work due to its first its geographic scope, which actually it covered all the Asian and Pacific region, and as well as the multiple sectors that you can see: the human health, urban energy, transport and aviation, agriculture, as well as environment. Here you can see some of the findings of the assessment, which was, for example, over 500 million people in India face medium to high levels of poor air quality from sand and dust storm. Also, the dust deposition affects cropland area, for example, in Turkmenistan, more than 71%, in Pakistan 49%, and in Uzbekistan 44%, which being significantly impacted. I don't go through the details. I just try to show you some of the highlighted. We worked extensively actually for the consultative, and not only with partners regarding the technical elements of the report, but also with member states as we move towards the findings. And we had sub-regional and thematic consultation with affected countries to begin developing the elements that went into the regional plan of action. The report itself received major media coverage, as you can see in this slide, and this included, for example, South Asia and East Asia, Singapore, Hong Kong, Iran, Pakistan, and other countries. The findings, as well as the significant coverage, which was in the region and sub-region, and reflects that reports focus on the impact specifically in urban areas and cities. Parallel to that, as we progressed with this work, we began working closely with our colleagues in ESQA, particularly the Arab Center for Climate Change Policy. We conducted the first inter-regional webinar, which highlighted the keen and interest and willingness of countries to collaborate in transboundary matter. As everyone knows that the sand and dust storm is transboundary. The regional plan action actually was endorsed just 9 months after the publication of the risk assessment report, and it was a really huge achievement which demonstrating a clear connection between the evidence and intergovernmental action. And the strategic framework of this action plan includes a deepening understanding, impact-based monitoring and early warning, and coordinated risk management, adaptation, and mitigation. The plan of action actually focused on these three areas. We are taking advantage of this opportunity to hold regular meetings to discuss various elements related to the implementation of transboundary initiatives. For example, we recently held a meeting in Tajikistan in order to examine the impact of sand and dust storm on glaciers. And as you can see in this slide, the methodology of this report risk assessment included several sectors, and actually for the risk, it has hazard, vulnerability, like exposure and sensitivity, and the resilience. As you know, sand and dust storm impact on 11 of 17 Sustainable Development Goals, and has a huge impact. And in order to focus on some kind of findings, I would like to remind ourselves that the significant human health impacts outlined in the report. I won't go into the details now, but they are very well documented in the report. For example, more than 80% of the entire population of Islamic Republic of Iran, Pakistan, Tajikistan, and Turkmenistan are exposed to medium or high levels of poor air quality. As you can see, the population in the different countries which are at risk, and the percentage of population in medium and high exposure. Another key findings that generated significant international media attention was the impact on urban areas. The report actually highlighted how cities are experiencing a growing number of dusty days with rising pollution levels and increasing population exposure. This is the area that we can work on at the international level because of its profound implication. And here you can see the dust exposure in urban areas in different cities, and the cities with more than 300 days of poor air quality due to sand and dust. And here you can see the big cities population, which their population is more than 5 million, with the highest number of days that the amount of dust exceeds 50 microgram annually. The other sector was energy. Renewable energy is an area of concern. Of course, sand and dust storm impacts infrastructure which are essential for renewable energy production, such as solar and wind system. And as we increase renewable energy production, it's critical to account for these effects to ensure the resilience of this kind of infrastructure. Here you can see the exposure and impact of SCS on energy sector. And the other sector was transport. In the transport sector, flight delays and cancellation due to sand and dust storm are a regular occurrence, and we have measured these impacts concretely, including their costs. Here you can see the risk in aviation sector due to lack of visibility. In terms of agriculture, the report identified the exposure of cropland in countries like Turkmenistan, Pakistan, and Uzbekistan. Going forward, we aim to assess which crops are most affected and the extent of those impacts, especially for some kind of key crops like cotton in Pakistan. Here you can see the exposure of agricultural land to average dust deposition. On the environment, the report also covered impacts on ecosystem, including glacier retreat due to sand and dust deposition. The meeting, which I have mentioned before in Tajikistan, was a classic example of how we transition from findings and analysis to agreement and follow-up action with a specific measure, which now is being implemented. Here you can see the exposure of glacier to average dust deposition. And finally, while the plan of action includes recommended action tailored to ESCAP region, it might serve as a framework for inspiration for similar efforts in other regions. The action outlined aim to enhance understanding, build resilience, and promote cooperation at both national and regional levels. So you can find this kind of recommended action for deepening understanding, as well as the impact-based monitoring and early warning, and coordinated risk management and adoption and mitigation. Thank you for your attention.
Thank you very much, Dr. Nilofan, for the interesting presentation about the successful international experience in dust storm management. Is there any comments, questions from the audience? Okay, thank you very much. Sarah, what is the next step? Okay, 10 to 15 minutes break only, please. Then we'll come back to the last session, correct? Okay.
at all these empty seats. We're waiting for you. Hello, ladies, walking over there. Hi. Come, sit down. We have such interesting speakers. Yes, hi. Assalamu alaikum. Yes, you've come to my pavilion. Enjoy the programming.
Yeah, it's working. Okay, it is supposed that the session ends now, but still we have some speakers. I want to invite Dr. Alan Al-Hamoud, if he's in the room. Yeah. If you can please, because you have another small talk. I hope that you can do in 10 minutes instead of 15, please, on San Andreas storms and health outcomes. And Dr. Ali Al-Hamoud is coming from the Kuwait Institute for Scientific Research. And yeah, sorry for being super late.
It's okay. Thank you very much. I will try to cut it short. This is the health impact of dust. Basically, I will talk about the PM 2.5 source apportionment. We have done 3 studies in Kuwait in cooperation with Harvard University and University of South Carolina, California, sorry. And we have done also the health impact, mortality and morbidity, 4 studies in Kuwait. So basically, as you know, PM 2.5, which is very fine particles, this is the human hair. Okay, so this is our hair. And if you consider the human hair is about 50 microns, 50 micrometers, then basically PM 2.5, as you know, is 2.5 microns, which is very, very fine particles, and there is also PM10. In other words, these are very fine particles that can be inhaled. We have done PM 2.5 source apportionment, توزيع مصادر الإغبار, source apportionment with Harvard University from Boston and Kisser. And as you can see in red during dust events, PM 2.5 of course is higher. And this is for 1 year at 2 locations in Kuwait, at two locations. The one on top, Kuwait City, and the one on the bottom is in the south. As you notice, of course, during dust events, PM 2.5 is higher. These are the samplers that we are using, and we have used these samplers during also Corona, أثناء فترة Corona. We have used it to determine the coronavirus in the dust. This is the Harvard samplers that we assemble at 2 locations in Kuwait, Kuwait City and the south. And basically, this is a comparison between America and Kuwait. So somebody might ask why we are considering the US, the United States. It's just basically, as you can see here, if we consider this study, actually we have done 2-year analysis from 2017 to 2019. We have collected dust particles, and we have analyzed it using XRF, and then this image here says 44% of PM 2.5 is from regional. In other words, it's from the region around Kuwait, because Kuwait is very small, so the source is regional, Saudi Arabia, Iraq, and so on. And then there is 20% from the sand. And also there is roads 17%. In other words, road here we don't mean traffic. We don't mean traffic. We means that when the dust blows on the road, then there is wind-blown dust. So in other words, the dust source and the road source, they are more of sand and dust storm sources. So we can say about 40% is from sand and dust storm sources. This is the PM 2.5. Now, if we consider the West, like the US, as you notice here, there is 32% from traffic. And then there is 30% from other sources. That is just gives an indication of how the PM 2.5 source apportionment differs from the US and the West, whereas the PM 2.5 is mostly from combustion product, and from our region where PM 2.5 mostly is from dust storms. This another study from also PhD student from University of Southern California. And here, basically, he says that in his study, mineral dust about 30%, and fuel combustion from about 24%. And the PM2.5 is about 60 micrograms per cubic meter. So, in other words, there are 3 students who have got their PhD Kuwaiti students, 2 from Harvard and 1 from California. Their results are kind of similar, where it says that traffic is about 20% and dust is about 30 to 40%, which is the constituents of PM2.5. And we have published this paper in environmental pollution. Also, we have published the other paper in environmental pollution from these PhD students. In terms of health impact, the dust particles, if it is inhalable, or thoracic or respirable. In other words, it depends on the size of the particle. If it is respirable, it means you can breathe it and it will go all the way to the lungs. And from the lungs, it will go to the blood. And from the blood, it may go also to the brain. So these are very, very fine particles, respirable particles. And this also shows also nasopharyngeal, tracheal, and pulmonary. Depends on the size. We have collected data from the Ministry of Health, cardiovascular diseases, ischemic heart disease, stroke, and respiratory diseases. So we have collected lots of data from Kuwait Ministry of Health, and also we have the PM2.5 data, and we try to determine the association. The first study, in terms of mortality and visibility, there was risk of mortality from air pollution exposure in terms of visibility. In other words, we have collected total mortality for 16 years data from fatalities, people who die, the counts, and also data for meteorological, and we found there is an association that there is higher risk of mortality during dust exposed days. And we have used a generalized additive model. And basically this is more details, where it says that non-Kuwaitis, males who are at certain age, adults, they have higher relative risk of dying than others. Why? Because these are, they are working outside. The higher risk of mortality during days with poor air quality, during low visibility. We have done another study relating mortality, not with dust, but mortality with PM2.5. And also we have collected data for 16 years, and we have identified that basically the relative risk is 1.012. In other words, there is a 0.12% increase is associated with PM2.5. And also in relation to cardiovascular diseases like heart, stroke, and so on. We have done a fourth study, which is the hospital admissions and PM2.5, morbidity and PM2.5. And also we came to the conclusion that after collecting 18 years of data, we noticed that Kuwaitis, females, and above 65 years old, they have higher risk of going into the hospitals because of PM2.5. And by the way, Kuwait, we have done these epidemiological studies. If we consider all the GCC as well as all the GCC, we have lots of studies related to the health impact and PM2.5 and PM10. The study number 5, I think this is the last study, also hospital admissions and PM2.5 sources. Here we would like to determine the source specific and not cardiovascular, but now we're looking at respiratory. It means lung diseases and so on. Also we use this for 2-year samplers. And then we came out, this is the conclusion, that basically from the sources, as I showed you before, there are sources: traffic, dust, regional, and others. We noticed that dust And the PM 2.5, they have high relative risk in terms of 0.16%. In other words, when there is a dust event, there is 0.16% of hospital admissions due to PM 2.5 sources. And this paper is also published in these journals. Thank you very much.
Thanks a lot for keeping short. Very appreciated. Is there any question? Yeah, Daniel?
I have a quick question on the traffic impact. That was negative compared to dust and PM 2.5 and a positive correlation. Do you have any idea why the traffic actually has a negative cause response coefficient?
Yeah, in terms of traffic, it is really, in terms of source apportionment, traffic only constitute 10% of the PM 2.5 in Kuwait. Mostly, it is the dust, which is 40%. Because actually, when we do the analysis based on the source apportionment, we are using EPA method, positive matrix factorization. After we do the analysis, for example, we determine what are the elements, aluminum, silica, iron, and so on, and we apportion this to the source. In terms of traffic in Kuwait, it is, yes, it is serious, but not as serious as the other sources. For example, of course, the dust, which constitutes 40%, or the regional also constitute 40%. Traffic only constitute 10%.
I think that Daniel refers to the traffic accidents, right? No, traffic, okay.
This is the reason, yeah.
Any other question? No? Okay, let's see if we can do a final discussion at the end of the session. Thanks a lot, Ali, for the nice talk. And now I want to invite the next speaker, that is Dr. Fahad Al-Rubai from the University of Tabuk. Dr. Fahad Al-Rubai? No, it's not in the room. Thank you for the warning. We have then, I don't know if Nilofar is still in the Zoom meeting, no? Nilofar? No, Nilofar. Letizia cannot stay. Then look for Nilofar, and if not, let me know that, no? Okay, no. Then let's go for the next speaker in the list, that is Professor Dr. Rafat Misak. Professor Dr. Rafat. You're here. You have a second talk today on hotspots of sun and dust in the Arab world. If you want to come, yeah. Yeah, if you want to sit and then, what do you prefer? It's okay, okay, better. If you sit, the people can see you. You can see the presentation here if you want, and you have here the pointer to move, and then the micro. With the green. Press the green share.
السلام عليكم. الموضوع the title of my talk is Enhancement Resilience to SCDS in the Arab world. Some case studies يعني. This is a very quick background. I'll skip it. We have COP13. Now, today, we have COP16. In COP13, there is some decisions regarding combating SDS and طيب ما شاء الله عليك. Just have a look to go to the second one. It is mentioned by UNCCD United Nations Convention to Combat Desertification in November 2023 that 2 billion tons of sand and dust equal in weight to 350 Great Pyramids of Giza enter the atmosphere every year. UNCCD experts attribute over 25% of the problem to human activities. And we will see how human activities play an essential role for what we call the anthropogenic dust storms. This is very important information about UNCCD country parties, which around 179. Here now, listed parties in COP16 is 197. Some 151 UNCCD countries, representing about 77%, are affected directly by sand and dust. So 151 دولة من ال 197 يتأثروا بالرمال. There's 45 country parties are source areas and classified as STS source area. And here you can see the categories affected and source areas. And you can see here in the photos, for example, there is storms from Egypt, and so we consider Egypt as a source area, and we will see after all. In Arab world, we have 22 countries. Based on the classification of the countries, based on their based on the effect of CDS, we have Saudi Arabia, Algeria, Egypt, Iraq, Libya, Sudan, Mauritania, and Syria represent 36% of the Arab countries are SDS source area. Other countries, including Jazr al-Qamar, Comoros Islands, and Djibouti, are SDS deposition area. And this is our classification, and maybe discussed further discussion for this classification, but this is based on my experience. This is, you have two stars. The upper one, SD source. SD source, you can go, start from Mauritania, Morocco, Algeria, Libya, Egypt, Syria, Iraq, Saudi Arabia. Other, which SD deposition, which, for example, Somalia, Yemen, Oman. This is the main sources of SDS in Egypt. You see regional sources from Libya and Sudan, and then we have local. In local, we have natural sources and anthropogenic sources. When we say anthropogenic sources, means land use related. يعني الأوف رود والسيارات اللي بتتحرك في الصحراء كل ده عبارة عن anthropogenic surface for dust and sometimes sands. The natural is classified into direct and indirect. The direct is sand dunes and sand sheets, sand seas. We have dunes, sand seas, and sand. Also, we have in the Western Desert huge sources natural, sandy dunes, napkas, whatever. Regarding the indirect, we are talking about the sources of STS. Okay, we discussed the direct. Now it's the turn of indirect. This is fluvial sediments. We mean by fluvial sediments the deposits which are transported by floods. Under Kuwait condition, within 2 to 3 weeks, this wet transported material become dry and very fine. Then land use, off-road, grazing, whatever, make it source, activate it, fine sand, and then carried by the wind. This is the fluvial. And also we have the sabkha. Sabkha is sabkha, which is wetlands, is very good source, but during summer, not during winter. And big list here for this anthropogenic, and you can see this map, which the Western Desert left here to this. Then sources of Kuwait. We have also natural. Same, we have direct, like sandy dunes, Naga, Loaimilei, Grishan. All these are direct sources. I just give examples. Indirect also fluvial, لما تحصل السيول ويبقى عندي flood plains. الفلاد بلينز لما يتكسر يبقى عبارة عن مادة دسمة للرياح تحملها مباشرة، وده بالنسبة للناتشرال. الانثروبوجينيك اللي هو اتكلمنا عليه قلنا لاند يوز ريليتد، ده يشمل الديستراكشن لاند يوز تايبس اللي هي من ضمنها الكامبينج اند ريكريشن والاوفر جريزنج والاوف رود والى اخره. بعدين هنا الجزء الثاني اللي هو periodically clear source of sand, like as I mentioned, the border trench between Iraq and Kuwait was established in 94, 95, and now it is a very huge collector for the sand creeping from Iraq. And every 3 to 5 years, there is maintenance, so they drag the sand and they get it in Kuwaiti side, and then it is a local source of sand and dust storm. The regional dust storms started coming from Egypt, crossing River Nile, crossing Red Sea, and then go to Saudi Arabia, Dahna, and all this sand seas there. And huge amount of dust carried by that. In Sahara Desert, I lived in Sahara Desert 25 years, and in Kuwait Desert another 25. So mixing between the Sahara Desert and the Kuwait Desert make reasonable experience. In the Sahara Desert, which is 9 million square kilometer, is huge sand and dust storm, as its dust emission are about 4 times as much as Adawiyah. 4 times. This is according to our studies under the umbrella of UNCCD. In Arabia, almost let us say 3 million square kilometer. Significant SD sources. الempty quarter اللي هو الربع الخالي، وده حوالي 503,000 كيلومتر مربع. النفود حوالي 82,000. الدهنة ساند سي حوالي 82 أيضا. This is sources of sand in Arabia, and the area of the source is clearly mentioned. This is again here Sahara Desert. This is the different sources. Great Sand Sea, which is number 1, and then very important source, which is number 3, sand dune belt of longitudinal type south the Qattara depression. I am trying to be very speed, and this is one of our field visits in one of the great sand seas in Libya. And you can see here our car in this red circle, and this is lake inside the sand sea called Obari Sand Sea. And you see here the dust storms from Western Desert, especially border between Egypt and Libya. All these are hotspots. Then in A, you have active sources of in North Africa. We visited the majority of these sources, and we have some tracking for these SDS sources. B, it is active sources of SDS, eastern fringe of Arabia. Also, we investigate this by satellite image. This is in Kuwait, some very important dust storms. You can see here Khiran Road, June 2013. You can see Salmi Road, March 2022. You see Chabad area in June 18, and Wafra Road, June 2017 217. اجتماع الدول الأطراف مرة تاني اللي هو الكوب 13 decision 31 combat SDS. This is decision of COP 13. For COP 16, you will see some decision related to the same issue, inshallah. Yani. And then adopt the UN CCD 2018-2030. This UNCCD framework consists of 5 objectives. Kuwait signed the agreement or the convention, and all Arab countries are, as I mentioned, state parties. So they have to start this strategic framework, and they have to develop their action plans. Objective number 1 deals with LDN, land degradation neutrality. Objective 2 is related to the enhancing the living conditions of the people affected by the SDS. Number 3, drought adaptation and mitigation. Number 4, just to make some agreement or protocol between different countries to manage for reducing the impact of SDS. 3 decisions during the period from 2015 to 2017. These decisions encourage countries and institutions at different levels to combat SDS. And you can see UN General Assembly, and then UN Environmental Assembly. And this is the number, and this is the date of these. All feel the destructive or the harmful effects of sand and dust storm, especially on the agricultural land.
1 minute.
تفضل. One minute? Okay, no problem. I have a case study how to protect Ali Salim airbase. ولا يهمك. This is some of the in parts of Saudi Arabia, and all these farms are under threat of STS, Bureda and Dahna. This is our plan for sand and dust storm risk reduction. Number one, monitoring and development of early warning system. Number two, risk assessment. Number three, identification, prioritization, and the controlling of sources. This is the number four, emergency and preparedness. Then R&D, and very important is to establish an early warning system. For those who are interested, the presentation is there, but I'll jump to how to protect. This is Ali Salim Air Base in 2013. Then other you have, it is on 2019. So you can see the difference between 13 and 19. Amount of sand. Just have a look. It is very clear that there is at least 20 to 25 increase of the sand budget. This is our, when I say our, I mean as a team in Kisar, not myself. We designed this system. We have number one, it is chain link, 2 meter high, 40 to 50% porosity. Then number two is a green belt, consists of 3 rows. And then the blue line is 3, which was already there just to maintain it, to have the complete system. And this is the design, and I discussed this design with our local experts and colleagues, and almost accepted. You have here biological checkerboard system, 10 by 10 meters, and here you have some trees like Zatzifas, acacia, and then plants in between the trees like Haloxeron salicornicum. And my last message, here you see very good green belt in Mutla'a area, Kuwait, and here people in the desert of China, called Kuboti, start a project of planting. My message, voice from North Africa, great green wall, to policy makers of SDS affected countries. What is the message? Put afforestation at the top of your agenda. And thank you very much.
I'm afraid that we don't have many time now, but if there is one very quick question with a very quick answer, we can take this question from the audience. No? Okay, just keep with us because we will try to have some time of discussion at the end of the session. Thanks a lot for your talk. Very nice. And I want to invite our next speaker because it's time to close the session and still we have 2 talks. Then I will ask the 2 remaining speakers to try to shorten your presentations as much as you can, please. The next speaker is Ishak Sulaimu from the National Center of Meteorology here in Saudi Arabia. And he will introduce this work on modeling PM2.5 pollution episodes during the Middle East springtime severe dust events. And he will discuss the model performance, spatiotemporal trends, and meteorological influences. You have here a green button for passing the slides, okay? No, the big one. Yeah, yeah.
Good evening, ladies and gentlemen. So I wish to stand on the assisting and establish protocols. I'm Isiaq Sulaiman Dimeji, and I'm a research scientist at National Center for Meteorology, Sand and Dust Storm Regional Center in Jeddah. So I'm here to take us through a presentation entitled Modeling PM2.5 episode during the Middle East severe springtime severe dust events. So we need to look at the model performance, the spatio-temporal variations, as well as the impact of meteorological variations. So the background and introduction. In 2022, the WHO ranked majority of countries in the Middle East as top polluted countries. And these are the ranking. Like Iraq was ranked the second in the world, followed by Bahrain. Saudi Arabia was ranked 15, and Iraq was ranked 21st. And as we have known that some of the reasons for this is due to rapid development, industrialization, and urbanization. So the Middle East has been suffering from severe dust event and also PM pollution, either PM2.5 or PM10. And high level of PM2.5 reduces the air quality as a result of dust, and also atmospheric visibility, so which previous speakers have highlighted and spoken about, and it has adverse health impact. So PM2.5 pollution is majorly formed from emissions, the atmospheric processes, as well as unfavorable meteorological factors, conditions. And regarding human health, I wouldn't want us to go through that one. A lot of presenters are talking about that one. So this is the monthly average of PM2.5 concentrations in the 7 representative cities in the Middle East. And as we can see that in Dubai, the daily PM2.5 concentration range up to like above 800 microgram per meter cube during May 2022 sand dust events. So to design effective emission control strategies, so based on a chemical transport model, because we have known that there are various ways of measuring air quality. So we have ground observations, we have remote sensing, we have modeling, we have machine learning. And this is an approach from the chemical transport model. So before we can rely on the result of the model, so we have to carry out the evaluation of model, and we look at the spatio-temporal trends and also the impact of meteorology, as well as the influence of atmospheric processes. So this study was simulated in May 2022 using, let me just go through, so the model used here was Community Multiscale Air Quality Model, CMAQ, coupled with WRF, and these are the configurations of the model. So in this study, a one-way double-nested domain was used, which was 12 kilometer and 4 kilometer resolution. So the result presented here has to do with 4 kilometer resolution. And this is the configuration. The emissions used was based on EGR 5.0, and fire emissions was used. And these are the mechanism used, SAPROC, TIC, and aerosol 6. And in this study, we found out that there were 4 atmospheric pollution episodes, and it was defined as the daily PM2.5 concentration that was above the interim 4 target of WHO, which is 25 microgram per meter cube. So the model evaluation was carried out on the meteorological variables, the temperature at 2 meter, the wind speed at 10 meter, as well as wind direction and thermometer, and this is the model performance. So averagely, T2 was slightly underpredicted in all of the cities. As you can see, the mean bias, they were all negative. Above all, the model performed very well, as we can see that the mean error in all of the cities were below the benchmark suggested, which is less than or equal to 2.0. Also, WS was also underpredicted, except in Abu Dhabi and Kuwait City. So slight over-prediction was, however, noted in other cities. Above all, so the statistical metrics were all below the suggested benchmark in evaluating the performance of the model. So also the wind direction performed excellently, except in Baghdad, Doha, and Jeddah, where slight under-predictions were noted. And this is the temporal trends of the meteorological variables, comparing the observations with the models. So averagely, as you can see that the WRF model was able to reproduce the observations of meteorological variables in the Middle East, and the temporal trends were captured by the WRF model. And this is the model performance of CIMAC in reproducing the PM 2.5 during the study period. So in all of the cities, there were under predictions, fine. So but they were very slight in all of the cities except Jeddah, that was over predicted a little bit. And so we can see generally that the CIMAC model was able to reproduce the PM 2.5 observations in the Middle East during the study period. And the temporal trends were captured. So this is the spatial trends of PM 2.5 meteorological variables in the Middle East. So IPM 2.5 in the Middle East, especially the coastal areas along the Red Sea and the Arabian Sea, were noted. And the average monthly T2 in the Middle East ranged between 300 to 310 Kelvin during the study period. And low relative humidity was also noted. And low PBL was also noted, especially along the Red Sea and the Arabian Sea. So spatially, there was low wind speed, average low wind speed. This is monthly average wind speed between 2 to 5 meters per second. So we look at the spatial temporal trends of PM 2.5 during the APs. So this is the average monthly PM 2.5 spatial temporal trends during the APs. That is the average of the all atmospheric pollution episode, the 4 atmospheric pollution episode. So AP1 was less severe compared to others, as the PM2.5 range between 80 to and less than 220 micrograms per meter cube. And AP3 was most severe, as we can see. AP3 was defined between May 12 to May 17. AP1 was between May 1 to May 11, while AP3 was defined as May 18 to 23, while the rest of May from 24 to 31 was the AP4. So AP3 was also severe, but especially was the most severe, especially in KSA, in the southwest of the KSA, the UAE, Oman, Qatar, and Bahrain, as well as Yemen. Low PBL and WS enhanced the APs. That is, the planetary boundary layer was very low during the period. And looking at the AP1, which was between May 1 to May 11, so this is we look at the influence of meteorological factors, which is PBL in this scenario and the wind speed. So we can see that from May 1 to May 3, so it could be termed as clean days from the figure 1, which has to do with PM 2.5, with higher PBL and WS across the region. But AP1 was more severe during May 7 to May 11, with daily increases in intensity, especially in areas along Red Sea and Arabian Sea. Low PBL was noted during the days of IPM 2.5 concentration, which is May 7 to May 11. For AP2, was also more severe than AP1, with higher concentration across the region. And the pollution intensity was higher on May 12, 13, 16, as well as May 17. Low WS and PBL, which is wind speed, could be seen that it enhanced the pollution during May 15 to 17, especially in empty quarter, which is Rub al Khali, the UAE, Yemen, and Oman. But AP3 was the most severe, as earlier stated, so with elevated PM2.5 concentration up to 600 micrograms per meter cube. And across the region, pollution intensity peaked during May 18 to 2022. Low WS, which is wind speed, and PBL also favor the formation of AP3, especially in KSA, the UAE, and Yemen.
2 minutes.
Okay. So this is AP4, was also severe but less compared to AP3. And region-wide, pollution intensity peaked during May 30 to 31, as can be seen on the spatial-temporal trends of PM 2.5. And also, as usual, the low WS favored the formation of AP4, especially in KSA, or May 24 and May 27 to 31. Conclusions and visual work. The meteorological feeds and PM 2.5 were well predicted by the WRF and CIMAC model respectively, with better agreement between the predictor and observations. And this study has revealed that the Middle East witnessed 4 atmospheric pollution episodes during May 2022 across the region with high PM 2.5 concentration. Unfavorable meteorological conditions enhance the PM 2.5 pollution during the pollution episodes, and effective emission control strategies to mitigate future PM 2.5 pollution in the Middle East are urgently required. And as earlier stated, that pollution is usually formed from 3 points: the chemistry, the meteorology, as well as the atmospheric processes. So it must be properly understood why formulating effective emission control strategies in the region. And this is the future work. So as the model performance has been evaluated and could see that the observations were well reproduced by the model, then we can rely on the result for further analysis. And the next thing to do is to do the source contribution of PM 2.5 and its major components, the sulfates, the ammonium, the nitrate, and also the metallic and non-metallic compositions of PM 2.5. So we have to do that one. So using the CIMAC model, and we identify and quantify the contributions of atmospheric processes, as we have said. So we have to look at the processes like the vertical transport, the horizontal transport, the diffusion, and look at what are the contributions to PM 2.5 and its components. And also, this is just a month study. So there is need to carry out long-term modeling, at least a year, for us to know the seasonal trends of PM 2.5 in the region before the emissions control strategies can be formulated, effective one. And also, this result now could be used along with Earth risk assessment models to look at the exposures and the Earth impact of PM 2.5 in the Middle East. So surely, we have a responsibility to leave for future generations a planet that is healthy and habitable by all species. That is a word from Sir David Attenborough. Thanks for listening.
Any quick question in the audience, from the audience? No? There is a quick question. Oh, it's coming.
Does CIMAC include dust generation? If yes, how did you do this?
Yeah, thank you, Prof. The dust model used was an inline model, an inline dust model within the model. So we have the result for dust, we have the AOD. So it's an inline, it's included in the CIMAC. So we have the result for the AOD of several nanometer and other radiation results within the model. So it takes care of the dust.
Thanks a lot. Sorry, because we need to move forward to the last speaker of today. Thanks again.
Thank you.
Our next speaker and the last speaker of the day is Dr. Tarek Hussein. He's professor in the Institute for Atmospheric and Earth System Research, INAR, and today his talk is about health impacts on San Andreas storms, which is quite general title. Let's see.
Thank you.
Yeah, this way.
Thank you very much, and good evening. It has been a long day. So I'm going to talk about the health impacts of sand and dust storm based on observation and some literature review. To start with, the exposure, we have 3 pathways of exposure. The fastest one is actually the inhalation, and I will focus on that with this simple model, which requires the exposure time, the level of exposure, and the breathing rate, and the deposition fraction in the respiratory tracts. The equation looks complicated, but actually it can be simplified to calculate the dose accumulated in the respiratory tract in different regions of the respiratory system, as it shows here, the three main regions, the head airway, the trachea, and the alveolar. And the deposition fraction, as shown in the figure, is quite different from region to another, and it's particle size dependent. So to apply this for sand and dust episodes, we try to figure out from ground observations what is the concentration level or the exposure level for that. And I picked up our observation in Amman regarding the size distribution of micron particles. And here it shows the concentration in the lower figure during this dust episode, which is coming from North Africa, Saharan dust episode. So basically the concentration of the micron particles between 1 and 10 micrometers increased from the normal level, which was around 1 particle per cubic centimeter, and increased to values above 10 particles per cubic centimeters. The other episodes that we observe also from kind of local, or I call it the Levant dust episodes, which is coming from Syria or Iraq, very close. In this case, the concentrations even came higher. And the third example, which is extreme dust episode, and this is a mix between Saharan and Levant event, and you can see the concentration goes about 90 particles per cubic centimeter. This is quite much concentration in 3 days, just increased suddenly. Basically, these are 3 examples to give us an overall of the particle size and the exposure level, and tells us that during sand and dust episodes, the particle concentration of the micron size fraction can be 100 particles per cubic centimeter. This is equivalent to PM10 concentration in the order of milligrams per cubic meters. During dust episodes, and based on our observations, the chemical composition changes quite a lot from the comparison to clean air masses, and sometimes it contains different types of microbes, bacteria, and viruses. I did not do it myself, but from the literature, it's evident that during dust episodes, there is a tendency for microbes cultivation in the dust particles. So if we consider this case as a geometric mean diameter of the accumulation mode about half micrometer and coarse mode about 2.5 micrometers, with number concentrations as shown here in the accumulation mode, 100 to 1,000 particles per cubic centimeter, and for the coarse mode, 10 to 100 particles per cubic centimeters, and assuming bulk density of the dust between 1.7 and 2.6 grams per cubic centimeters, we come up with the result that the inhaled dose rate for an adult male is ranging between 2 to 15 milligrams per hour during rest conditions. And it can be even higher if this person is exercising or doing extensive movements, reaching between 30 to 155 milligram per hour as inhaled dose rate. The regional dose rate also changes in different regions of respiratory tract. For example, the largest fraction in the alveolar region during exercise, and the largest fraction is about 66% in the head region during rest. So it varies from region to region according to the condition of activity of the person exposed. The final remarks here says that during dust episodes, the exposure level of these particles is quite large. And the effect, the health effects depends on the status of the subject, the people, the age group, and the health status. And we have two cases, or let's say two distinguished exposures, the short-term exposure and the long-term exposure, and short-term effect and long-term effect as summarized in this slide, so I would not read them totally, but the most important one, which is almost everybody is suffering during sand and dust storm, which is the short-term exposure, and it appears immediately, saying that we have eye irritation, immediate coughing, sometimes dry throat, dry eyes, and so on. So the last remark says, desert dust may cause respiratory diseases, cardiovascular diseases, cardiopulmonary diseases, mental health issues, if you think about the stress that is imposed to that. And sometimes it goes beyond the health effects to, like the direct health effects, to indirect health effects, if we think how the dust induces the loss of visibility and then induces the car accidents, and then we get injury because of these accidents. And that was all. Thank you very much.
Thanks a lot for the short talk. Any question from the audience? In the pavilion? Someone? No? Then we have 10 minutes for a very quick final panel. I want to invite Juman, please. You can stay, Tarek. Dr. Ali, please. Also, you can join us. Daniel, I think that you were also in this final round table. Who else was in this round table? Please take a seat. Abdul Majed Haddad, I don't know if he's in, I think that he left, right? Abdul? Yeah, I think so. I will sit with you just for keeping the gender balance in the panel. I don't know if any of you wants to start with final remarks. We received some final remarks in one of the sessions that I think that that's really the most important key things that we have to keep in mind. Shaped the strategy based on the amount of dust and the properties of dust, but also it's important the sector and how we can engage the other sectors to help us to promote more data. Probably is one of the key questions. You have my
Is it working? Okay. Hi. Thank you all for staying with us. I have a very selfish proposal because tomorrow the SDS Awards Global Steering Committee is going to be starting to think about the next 5-year plan. Right. So I have a challenge for the audience and also the expert here. What do you think is the number one dust issue that you want to work on? So anybody like to shed some light? What do you think is the most pressing SDS issue that we should be working together on?
For a scientific point of view or assessment point of view, or
Well, it can be anything, right? So
okay.
The full cycle of SDS, from source to impact and to mitigation.
No, it is not one. There is no one question. So we just discussed that it is a complex of questions that should be considered together. So, and I think one of the important things is, of course, dust generation and size distribution of generated dust.
I agree that it cannot be one. One is very difficult. But I think looking at the life cycle of dust from generation, which ideally if we can mitigate there or reduce there, that will solve a lot of the problems. But I think there is a very fundamental question on the health impacts at source region and downwind and receptor. because currently a region like ours here will never meet the WHO guidelines. The reputational damage, environmental damage for reputation for not meeting guidelines that are set on data that does not include dust is very big. So coming up with the evidence required by the WHO to show either way. We have to show either way. And I'm not talking about epidemiology. Epidemiology is great and important, but we have to go deeper than this. Exposure and toxicology studies on dust regions to show if WHO should take into account this or not into the mass guideline.
And here I want to stress something of the guidelines, is science evidence. Then the lack of studies in your region is the main reason where dust is not stressed in the guidelines, and is in the guidelines always you can see this quota text that is telling us, and look, we are not having enough studies in desert dust regions, and we need these studies.
I fully agree, and I think this is what I'm saying here is a call for regional collaboration on studies at dust at scale. And I've been here in this region 3 years, and this is really what I'm pushing for in the region where I work, but this should be a regional effort. The more we do it together, the better and faster we can achieve these results. WHO can only base their evidence on peer-reviewed literature. So that's really a call for the action.
I hope that some countries in this great event will receive these messages. There are some comments here.
Thank you.
Someone is taking note of these recommendations, right? We will take a final round of recommendations, maybe. Go, Peng. Go.
Thank you, everyone. Thank you for hosting this discussion, and agree that there is no one, focal point. Everything is important as we, over the last decades or so, like more and more, I think attention was put on the impacts of dust on various aspects. But I want to stress that since we already know the impact, it's very important, and we need really good dust forecast. So I want to stress on the science part of that because I do aerosol studies besides dust, like pollutions, and we see over the past 2 decades, say from forecasting models, doing both forecast of pollutions and dust and fires, we see those gradual improvement in pollution forecasts. We see, very clear, actually, very clear evidence in that, but not much in dust forecast. So I'll talk about that in tomorrow's roundtable. So I think, dust is important, but, it's very challenging compared to pollutions, like anthropogenic pollutions, because over the past 2 decades, those emission inventories for pollutions is improved and made available. But for dust emissions, it's still a challenge, even though we have, finer resolution models, but those sources and the life cycle, the science behind that, like the deposition fluxes, those processes that would help scientists to improve our understanding of the dust processes and better making forecasts are still relatively lacking compared to pollution side. Thank you.
Yeah, if I may.
I think you, Peng, just steal my idea, but I will just elaborate a bit more. Actually, I think this time in front of us in a few years from now, maybe 10 years or so, to really go toward the real warning systems for dust. And this means what Peng was already elaborating, model with a high resolution, models that takes up better data on sources, which are, I think we are not a good, we are in a good road for that. Better observations, because as usual we want to be sure that our forecasts will compare well with the observations. That's, I think, all I wanted to say. Thanks.
Yeah, if I may add something, I think there should be more emphasis on the scientific research, as Mr. Jum'an mentioned in the beginning of this event. Scientific research really is the, you can say, is the drive for the results. For example, for air quality forecasting and so on. In other words, during coronavirus, when there was complete lockdown in many countries, we have done a study during that time. And as Dr. mentioned, when there is complete lockdown and there is no source of pollution, air quality improved much in the world. But in our region, at least in Kuwait, when we have done this study, still PM2.5 and PM10 could not meet even the interim targets of WHO. Interim target 1 or interim target 2 or interim target 3 could not reach that. Why? Because there is dust haze. There is the suspended dust particles. Air quality was very improved. PM2.5 was reduced from the regular, let's say, 45 micrograms per cubic meter. It was reduced even below up to 20, but still could not meet the WHO air quality guidelines. Another important issue is we need to do more research on the complex chemical interaction between meteorological and dust. For example, we have done just recently, we have published a paper, and there is really very complex interaction between meteorological factors and dust in their contribution to the PM2.5 and PM10. So in conclusion, I think there should be more effort and more funding for scientific research and coordination between the different countries.
Well, if I will say something, I know it is now late and we need to go home. But anyhow, I think the challenge that we have as a scientist is to help the people, help the nations that they want to overcome this challenging issue. Having a good data sets and deploying more monitoring stations for sand and dust storm is a key, because that will not help us here, and maybe after 20 years the people who can use still the data that we are collecting now. So I think the investment in getting good data is one of the main goals that we should focus on. And thank you very much.
Hello everyone. Just a final comments for, I have experience in air quality modeling and air quality monitoring, both in the UK about 10 years and now here in Saudi Arabia, have about like a 5-year experience. What I see actually, when we monitor air quality in the UK, the main pollutant of concern, there are two pollutants. One is NO2, nitrogen dioxide, which has high level near the junction of road traffic, near large roundabout, and also PM2.5, which is emitted, or nanoparticles which are emitted by road traffic. Okay, in Saudi Arabia, or as we've been talking about this afternoon and the whole day, here the situation is different, okay? Even if you take out all the traffic from the urban area, there will be still that, as you said again and again, the PM2.5 level, PM10 level will be still higher than the WHO guideline. So what recently I've been working on one of my paper. What I think we should be recommending, that when we compare the level of PM10 or PM2.5 in Middle Eastern country, or Saudi Arabia especially, we should be taking, subtracting the natural component from the total component, from the total observed concentration, and then to find the anthropogenic component, that should be compared with the WHO standard. And that's how we could, there is a possibility. Because Sarah is laughing, this is the natural pollution. It has been there for centuries and centuries. The actual pollutant of concern in the modern age is the urbanization and the road traffic emission related to industry stuff. So this is this is the thing I think we should be worried about more rather than, I know on a large level there are action and there are policies about how to control desertification, drought, sand, and everything. But the main pollutant, which is actually the pollutant of concern, Europe, UK, US, that is the anthropogenic component. And I think that is something with the policy we should recommend. Actually, this is the component from anthropogenic sources that should be compared with the WHO limits rather than the total observed concentration. Thank you.
I will give you the word, but let me just put on the table two questions. When you're measuring PM2.5 in cities and you have dust, sometimes it's resuspended dust, meaning that it's traffic action who is elevating this dust and then becomes now anthropogenic, not natural. Then to do the subtraction of what is resuspended dust, because the traffic and what is coming is not easy, first thing, how to do this distinction. But the WHO guidelines, what it's telling you is what you're really breathing and the risk that represents to breathe this amount of dust or other components in your health. You can justify why for national standards you put another threshold or another methodology. In Europe, they discount the exceedance due to natural reasons like Saharan dust as not having any legal consequence. This is air quality, but the WHO are references connected with health. And here the question probably, that is the question that many people in Middle East is telling to WHO is, but I think that the people is dying less in Middle East than in Europe. We don't know. We don't have any proof. Then again, I think that you agree with me that we need these mortality rate studies to really go to WHO and say, look, WHO, the reason why the people is dying is not dust, is the component of PM2, PM1, because it's black carbon, or it is, and this is the key question that you have to disentangle in this discussion. I will pass you the floor.
I just very briefly, I think you've answered this very well already. I think the discussion should be separated between compliance, environmental compliance, and health. These are not the same. For environmental compliance, the rules in the EU and others allow you to discount natural volcanoes and dust and others from your exceedances. That's easy. For health, you breathe in everything. Now, there is a factor here when people say about in this region for generations and generations dust existed. But what did not exist is the massive, massive man-made pollution, urbanization. Now, the literature shows already toxicology of virgin dust, clean dust, is not as bad as dust mixed with urbanization. The toxicity increases after interaction. Very simply, if the acidity of the dust changes with sulfuric acid deposition, you liberate some of the minerals. You become more soluble. If you change the pH, and that changes the health impact. So we need these studies. We have to collect the evidence here and show this, and then we can make discussions.
And also keep in mind the secondary chemical reactions, because on top of dust, sometimes you have peaks of ozone, peaks on NO2, then it's these multi-hazard studies that we have also to be in mind, also heat plus dust plus and this is also part of the early warning systems, how we can integrate all these components that can be a risk for your health. But it's true that we cannot discount what we breathe. Legally, we can do it for air quality, but it's what you breathe, and we need to understand if you are having major risks in your health, if you are breathing this amount of aerosols or not. I will pass you the floor to Juman, because I'm looking now at the time, and we are We recovered a little bit delayed. It's not 2 hours, it's just 40 minutes late now. And I don't know if we have to close the session or... I'm closing. I have the power today.
I open, you close.
Okay, then a little bit late, 6:10 Riyadh time. Thanks a lot to all of you for staying the whole day with us. I hope that you enjoy all the talks. Thanks a lot to all the experts, speakers, invited participants, all the people that make possible this day. My panel to be with us.